It began quietly, like a breath caught in the throat of the cosmos. At first, no alarms, no headlines, just a few lines of new data magnitudes, timestamps, coordinates tucked inside a monitoring log from an observatory in northern Germany. The object was listed as 3I, Atlas, the third interstellar visitor ever recorded by humanity, a faint smear of light drifting through the solar wind on a hyperbolic path that would never return. It was supposed to be forgettable, a distant traveler passing by, its orbit already mapped, its brightness stable, its story simple. Then, overnight, the numbers changed. Brightness that should have fluctuated by fractions of a percent leapt upward by orders of magnitude. The line of data widened, as if the object itself had inhaled. At 2:17 UT on November 9, amateur astronomer Frank Nebling checked his stacked exposures and thought his calibration had failed. The field looked wrong. The faint grey dot had become a sprawling, radiant blur that stretched across the sensor like a miniature nebula. He recalibrated. He restacked. The anomaly persisted. 300 kilometers away, Michael Buchner, running a nearly identical rig, captured the same phenomenon within minutes. 2 independent instruments, 2 identical outbursts. The odds of a processing error aligning that perfectly were microscopic. By dawn, their message threads filled with disbelief. Check your focus? Checked. Ghosting? None. Then what are we looking at? No one could say. When the data reached the minor planet center, analysts assumed misalignment, perhaps scattered moonlight, but calibration stars looked fine. Exposure timing matched, photometric baselines confirmed. 3I, Atlas, had brightened by roughly 1,000-fold. For scale, that's like watching a candle swell into a bonfire while insisting nothing has changed in the physics of flame. Observatories from Chile to Japan pointed their instruments toward the coordinates. Some caught only faint residual haze, the glow already fading. Others saw the tail end of an expansion so vast it blurred their frames. The object's visible diameter now measured hundreds of thousands of kilometers, as though a small moon had unfolded a luminous shroud around itself. Astronomers are cautious by design. They distrust drama. Yet the chat channels that night were anything but calm. Words like unprecedented, non-cometary, and structural appeared again and again. Something had shifted, and not just in the sky. If you could stand where that object drifted 326 million kilometers from Earth, you'd see sunlight scatter off a vast translucent envelope. 2 radiant filaments extending from a compact core, one streaming outward into the dark, one reaching back toward the Sunday. They called them jets, though no one understood their source. To the eye, they resembled arteries of light matter flowing where physics said it couldn't. Initial models tried to fit the brightness curve into known behavior, maybe a burst of volatile ice, maybe a rotational fracture. But the energy output didn't fit. To generate that kind of expansion naturally, the object would need to vent mass at impossible rates, emptying itself within weeks. Yet its trajectory remained stable, its velocity unchanged. That's when the unease began to settle in. On astronomy forums, professionals hid behind cautious language. Further observation required. Possible geometric amplification. Private interstellar objects were supposed to be cold, inert, lonely stones. They were relics of other suns, wanderers expelled by gravitational chaos eons ago. They didn't glow like living things. They didn't expand overnight. And yet here it was. Every frame told the same quiet truth. An object the size of a mountain behaving like a system with intent. As the data propagated through scientific networks, researchers began cross-referencing photometric histories. Archive images from August and September showed nothing unusual. A standard faint coma, tail barely measurable. Whatever had occurred between October 20 and November 9, right after perihelion, when 3I, Atlas, swung behind the sun from Earth's point of view. Meaning, whatever transformation took place, it happened out of sight. The metaphor wrote itself something changing while hidden behind the sun, emerging unrecognizable. When sunlight finally reflected off its new form, every telescope that caught it saw the same impossible geometry. Twin plumes, symmetric, structured, luminous, one directed away from the sun, as expected, the other, impossibly, toward it. That's when the murmurs started. At the Jet Propulsion Laboratory, orbital analysts ran the updated coordinates through their trajectory models. The orbit still traced a hyperbolic escape, eccentricity about 6.2, but small deviations hinted at non-gravitational forces. They were subtle, almost within error margins, but consistent enough to raise eyebrows. Non-gravitational acceleration means thrust, however faint. Yet there was no visible outgassing that could explain it, except these new, colossal jets. A paradox. Material streaming in both directions, yet no measurable recoil large enough to alter the path. It was as if whatever energy drove the expansion cancelled itself perfectly, maintaining balance while rewriting the object's appearance. Nature, in all its chaos, rarely balances equations so neatly. By the second week of November, social feeds were awash with side-by-side comparisons. July's modest smudge beside November's cosmic blossom. Captions read, "The comet that became a world, interstellar chrysalis, space just woke up." A few even suggested a more provocative framing. Construction event. Most scientists ignored the noise. They focused on spectra, trying to isolate signatures of known ices, H2O, CO2, CO. The ratios looked odd. Carbon dioxide dominated, water faint. A CO2 H2O ratio around 8:1 unheard of for solar system comets. The pattern hinted at something ancient, irradiated, interstellar indeed, but it didn't explain the symmetry, nor the sun-facing jet. That remained the quiet question behind every late-night data call. Why is it pushing light against light? When Harvard's Avi Loeb finally weighed in, his words were careful but electric. "If the data hold," he wrote, "we may need to expand our imagination before we expand our equations." That sentence ricocheted through the community. Some called it reckless, others necessary, because everyone knew what he was implying without saying. The possibility that this was not purely a natural reaction, but an operation. No one wanted to believe it. Yet disbelief no longer comforted anyone. The expansion continued to confound every model. If sublimation caused the bloom, it should fade as the object moved farther from the sunday. Instead, brightness stabilized, as though a process had reached equilibrium, a self-regulating system. Weeks passed. The jets held their shape. The solar wind howled past at 400 kilometers per second. Yet those filaments remained straight, dense, aligned. A cometary plume should twist, ripple, and disperse. These did not. They looked engineered, and that thought, unspoken but shared, spread through observatories like static before a storm. Because in science, the most frightening word isn't alien, it's impossible, and what 3I, Atlas, was doing fit neatly inside that word. What if we're not seeing a comet brighten, but a mechanism awaken? How small we seem, staring at something that changes faster than our certainty can keep up. Sometimes, the universe doesn't whisper new laws of physics. It shows them to us and waits for us to notice. By month's end, the last confirmed visual magnitude had settled nearly 1,000 times higher than baseline. The object's coma stretched millions of kilometers, reflecting sunlight like an unfinished mirror. Nothing in our databases matched it. We named it an anomaly, but it felt like an introduction. And then, it aimed jets at the sun. When something grows that fast in space, every instinct says you're seeing a trick of the light. But this time, the light itself was the trickster. At first, astronomers thought the object had fractured, maybe a collision, maybe internal pressure bursting its icy crust. Yet deep field imagery revealed no debris field, no secondary fragments tumbling into the void. What they saw instead was a luminous sphere of dust and vapor, expanding symmetrically, like the slow pulse of a heartbeat frozen in a vacuum. It wasn't an explosion, it was inflation. The coma of 3I, Atlas, that halo of gas and dust surrounding its core, had swollen to more than 1,000,000 kilometers across, dwarfing even Jupiter's diameter. For a few brief nights, it became one of the largest visible structures in the solar system. And yet, its nucleus was still invisible. The center remained hidden inside a veil of reflected sunlight so smooth it seemed artificial, its edges blending seamlessly into the black. Every instrument measuring its brightness registered the same curve, a sudden vertical rise, followed by a stable plateau. In other words, not a flare, not a decay, just a state change, as though the object had turned something on. Telescopes using polarized filters noticed something else. The light wasn't scattering evenly. There was a faint axis of alignment, an orientation pointing almost directly toward the Sunday. That detail seemed minor at first, but in retrospect, it was everything. The so-called anti-tail appeared next. Ordinary comets trail material away from the Sun, blown outward by solar radiation pressure. But 3I, Atlas, produced a narrow filament in the opposite direction, a brilliant streak that seemed to connect it to the Sun rather than repel it. To most observers, it looked like an optical illusion, a mirage produced by viewing geometry. To those who ran the calculations, it looked like defiance. Because even after correcting for angle and parallax, the jet still leaned sunward. Its luminosity fluctuated in rhythmic pulses, faint but measurable, as if modulated by an unseen clock. That's when data analysts began to realize they weren't looking at chaos. They were looking at choreography. Spectroscopic measurements poured in from observatories across 3 continents. The comet's composition read almost sterile. Dominant CO2 lines, trace amounts of sodium, magnesium, and an unknown emission near 389 nanometers that didn't correspond neatly to any expected molecule. Some called it a calibration glitch. Others called it a signature. The comet expansion rate, about 200 meters notas to the power of -1, was far too fast for thermal sublimation alone. Even with extreme heating, ice wouldn't sublimate that violently without tearing the nucleus apart. But 3I, Atlas, remained intact. In fact, orbital refinement showed its mass distribution hadn't changed enough to explain the energy expenditure. So, where did the force come from? No visible vents, no fractures, no cryovolcanic outbursts, just that steady bloom, symmetrical and deliberate. A simple metaphor began circulating among researchers. Imagine holding a balloon to a candle, but instead of melting, it inflates and the candle grows dimmer. Something in that comparison captured the unease. Because as the coma expanded, the surrounding solar environment subtly dimmed spectrographs, recorded localized drops in solar scatter intensity. Some thought it a coincidence, some whispered an absorption event. The object, it seemed, wasn't just reflecting light. It might have been manipulating it. By mid-November, NASA's infrared telescope facility on Mauna Kea picked up thermal readings suggesting that the coma's outer layers were colder than the surrounding solar wind. That defied every model. Gas released by heat should cool gradually outward, not instantly form a cold shell. Yet, data showed a near-perfect inversion, a chilled cocoon wrapped around a warmer interior. Like a thermal suit, one physicist joked in an internal chat. Nobody laughed. If this were natural, it would require microstructures, dust grains, arranged to reflect and refract radiation with engineered precision. If it weren't natural, then someone or something had built a device capable of controlling radiative balance on an interstellar scale. Meanwhile, amateur astronomers worldwide began uploading images, showing a faint ring around the expanding halo, a ripple of brightness that moved outward at regular intervals. At first, the intervals seemed random. Then, when plotted on a logarithmic scale, they formed a clean exponential decay, as though each pulse carried slightly less energy than the one before. Some saw the pattern and immediately thought, signal. Others said it was just physics, a resonance effect, as gas density decreased. But even those explanations couldn't ignore how precise the decay constant was. Too smooth for turbulence, too consistent for randomness. And then there was the colour. In early December, the European Southern Observatory released composite images showing an eerie turquoise hue dominating the outer coma, a wavelength between cyan and emerald, not typical for carbon compounds. The colour matched no known spectral emission from CO2 or H2O under those conditions. That glow became the icon of the event, a ghostly green orb hanging against the black, its brightness unwavering, its centre hidden like an eye behind frost. To some, it was a celestial chrysalis, an object shedding one identity for another. To others, it was a mirror, reflecting not what it was, but what we wanted to see. Either way, humanity was watching something that refused to behave like debris. Back at JPL, orbital simulations ran endlessly. Each new dataset forced recalibration. No matter how they tuned the parameters, they couldn't reproduce the expansion without adding one variable: internal pressure, driven by a non-thermal mechanism. Some speculated electrostatic discharge, others microfusion of trapped hydrogen pockets, but none explained the coherence of the jets or the persistence of the geometry. One young engineer, half in jest, labelled his model reaction-controlled comet. The term stuck. Whether or not it was built, 3I. Atlas moved, as if aware of its environment, balancing thrust, modulating output, maintaining symmetry. For days, the global science community oscillated between awe and denial. The phenomenon was real, the data consistent. But the implication that we might be witnessing a designed process was too heavy to carry without breaking the discipline of objectivity. So they did what scientists do best. They measured. They plotted. They waited for the data to decide for them. And in that waiting, something subtle shifted. Not in the sky, but in us. The tone of the conversation changed. Awe replaced disbelief. We stopped asking if it was possible. We began asking how. Every new image seemed to mock our understanding. The coma's edge sharpened instead of blurring. Its internal brightness gradient formed layers like nested shells. And through all of it, one alignment held, a central axis pointing directly toward the sun, unwavering as though drawn by design. The solar alignment wasn't incidental, it was intimate. Whatever 3I, Atlas had become, it wasn't just reacting to sunlight, it was engaging with it. But what powered that bloom? It was even stranger. In the vacuum of space, motion should be honest. No atmosphere to cheat, no drag to disguise. Every push has a pull, every action leaves its mark. But 3I, Atlas had begun to move, as if inertia itself had forgotten the rules. At first it seemed simple, another comet releasing gas under solar heat. Outgassing causes thrust. Thrust alters trajectory, routine, expected. Until analysts at JPL's Orbital Solutions division noticed something they couldn't unsee. The direction of the push didn't match the motion it caused. It was the kind of inconsistency that keeps engineers awake, an acceleration that pointed the wrong way. When they overlaid successive trajectories, the pattern defied symmetry. Instead of curving away from the sun, 3I, Atlas, appeared to nudge slightly toward it, as if drawn by an invisible tether. No known comet had ever done that. Not even Oumuamua, the previous interstellar wanderer, had shown anything so cleanly reversed. To confirm, they reran the JPL ephemerides with updated astrometry. The residuals, the tiny differences between predicted and observed positions, showed a consistent offset. A small, stubborn acceleration of roughly 0.02 millimeters per second squared. Tiny, yes, but over weeks, it compounded into kilometers of displacement, a whisper of motion in the wrong direction. One analyst stared at the residual plot for hours before muttering what no one wanted to hear. If this is real thrust, it's firing the wrong way. That sentence hung in the room like static. They checked for every alternative. Solar wind fluctuations, measurement bias, dust contamination, but the vector held steady through multiple telescopes, across multiple nights. The odds of coincidence? Less than 1 in 10 million. So the question turned from is it real to why would it do that? The simplest answer was geometry, a trick of perspective. Perhaps the jet only appeared sunward because of our viewing angle. To test that, they ran 3D simulations using parallax from 2 widely separated observatories. One in Hawaii, one in Chile. The result made even the skeptics fall silent. Both observers, from opposite hemispheres, recorded the same alignment, a collimated stream of gas, anchored at the nucleus, extending directly toward the sun's coordinates within 1 degree of perfect opposition. That wasn't an illusion. That was the intent. For days, researchers argued over the physics. How could material be accelerated against solar radiation pressure, the very force that defines cometary behavior? Solar photons should push dust and gas away from the sunday, but the jet fought back, flowing upstream like a current against gravity and light. One team in Prague proposed electrostatic repulsion. Maybe the nucleus carried a charge differential strong enough to channel ionized material inward. Another team at MIT suggested magnetic reconnection events in the solar wind could briefly reverse plasma flow. Yet neither model explained the coherence of the jet, its clean, unbroken line stretching millions of kilometers. unaffected by turbulence or solar flares. It behaved less like a plume and more like a beam. Images from the Solar and Heliospheric Observatory, SOHO, offered the first clue. When the sun-facing jet flared, nearby coronal filaments responded milliseconds later, tiny oscillations rippling outward as though reacting to an unseen pulse. The timing suggested interaction, maybe even synchronization. A senior plasma physicist at NASA quietly wrote in his notes, "Coupled system? Feedback loop?" He never published it, but the thought spread anyway. Because if this was feedback, 3I Atlas wasn't merely venting, it was communicating with sunlight. By now, the object's motion had broken the clean simplicity of Newtonian prediction. Normally, once a trajectory is set, every update refines toward stability. But the latest solutions diverged. Each new observation forced a fresh correction, as though the object were adjusting itself in response to being measured. Astronomers joke darkly about observer effect in real life, but beneath the humor was unease. The equations weren't just failing, they were mocking us. In December, Gaia DR3 data confirmed a subtle precession in the object's axis of rotation. Something was steering it. Not much, just a fraction of a degree per week, but always keeping that impossible jet aimed sunward, unwavering. To maintain that alignment, naturally would require internal gyroscopic correction, a mechanism capable of sensing solar position and reorienting the body accordingly. No rock does that. No comet knows where the sun is. And yet, this one did. Across social media, the story metastasized. One headline screamed, "The comet that pushes toward the sun." Another whispered, "Alien propulsion system discovered." Scientists tried to distance themselves from the noise, releasing conservative statements about non-gravitational acceleration consistent with unknown outgassing. But even in academic papers, the unease bled through the careful prose. One line in a European Space Agency bulletin stood out. The observed dynamics challenge the traditional comet model and may require rethinking how we define reactive forces in a vacuum. Translation. The math was breaking. Meanwhile, spectrographs kept catching something stranger. Every time the sunward jet flared, a brief dip appeared in the reflected solar flux like a shutter closing for milliseconds. Some thought it was a coincidence, others suspected an instrumentation glitch, but when 3 separate observatories recorded the same pattern, the conversation shifted again. Maybe the jet wasn't only emitting material, maybe it was absorbing light. If so, that meant controlled photon interaction, an efficiency no known natural process could match. Even among skeptics, there was a reluctant fascination. One senior researcher put it best, "It's not that we think it's artificial, it's that it's performing calculations that nature doesn't usually attempt." Because each burst, each pulse, each reorientation of that sunward jet maintained exact proportional balance with the object's changing velocity. It compensated for motion before motion occurred, like a pilot adjusting course mid-flight, not afterward. And still, no visible energy source, no heat signature, no engine, just motion, in defiance of reason. By Christmas week, the debate had fractured into camps. The naturalists insisted on exotic physics, maybe CO, 2 jets directed by microtopography, perfectly timed with rotation. The technologists whispered about Bracewell probes, self-stabilizing relics built to harvest solar energy through resonant reflection. And the quiet ones said nothing at all, because they'd seen the unfiltered telemetry, the one dataset still classified by JPL, that showed something no one could explain. For 15 seconds on December 12, the object's acceleration vector flipped, then flipped back, without any measurable change in velocity. The data fit no model. There was only one possible conclusion left to write in the margins. The object resisted correction. By now, disbelief had softened into awe. We weren't just watching an anomaly, we were witnessing a dialogue between matter and light, physics and defiance. Every pulse, every shimmer in that sunward jet seemed to whisper something, that maybe gravity isn't the only language space speaks, that maybe motion can mean more than movement. It's not just the direction, it's the math behind it. In science, the most dangerous sound is silence when the equations stop arguing back. For weeks, every new set of coordinates for 3I, Atlas, came in clean, precise, and wrong. The models worked perfectly until they met the data. Then they fractured like glass, cut by its own reflection. The Jet Propulsion Laboratory kept revising the orbit, feeding in new measurements from Hawaii, Chile, and the Nordic Optical Telescope in Spain. Each update should have refined the curve into clarity. Instead, the curve began to wobble. It wasn't chaos, just disobedience. On paper, 3I, Atlas was supposed to be simple. A visitor on a hyperbolic escape, eccentricity E is approximately equal to 6.2, inbound velocity around 61 kilometers per second, a clean arc bending past the sun before coasting back into interstellar dark, a cometary cameo, a one-time appearance. But when the sun-facing jet began to fire, the velocity residuals stopped behaving. The numbers refused to align with gravitational expectations. A faint but measurable drift crept into the orbit, so subtle at first it seemed like noise, until it stayed. By late November, the predicted coordinates and the observed positions were off by tens of arcseconds. That's not a rounding error, that's a rewrite. Analysts tried everything. Adjusted the solar wind model, recalibrated albedo assumptions, refitted mass estimates. Nothing held. The object's path wasn't chaotic, it was too stable. The acceleration wasn't random, it was tuned. Every deviation compensated for the last, keeping its trajectory from unraveling, as if self-correcting in real time. Imagine throwing a stone, one orbital engineer said, and the stone corrects your aim mid-flight. It was meant as a metaphor, it didn't feel like one. By December, the object's calculated perihelion distance had shifted by 0.004 AU. A small number on paper, but massive in celestial mechanics. That difference alone could alter an interstellar trajectory by billions of kilometers over time. The problem wasn't that the object moved, it was that it seemed to know where it was supposed to be. Every time scientists adjusted one variable, the object compensated through another. If they increased the outgassing parameter, the acceleration vanished. If they decreased mass, the angular velocity corrected itself. It was as though 3I, Atlas, had learned the equations we used to predict it, and was politely declining to participate. In orbital dynamics, there's comfort in chaos. Randomness you can average out, errors that follow a curve. But 3I, Atlas, refused entropy. Its behavior was deterministic without being explainable, precise without being predictable. When JPL analysts ran Monte Carlo simulations to estimate uncertainty, the scatter plots didn't scatter, they spiraled. That spiral became the symbol of the crisis, motion caught between math and myth. The public never saw the early internal memos, but a few lines leaked online, stripped of classification. One read, "Model diverges under all known forces. Recommend alternate frame of reference." Another, "Object displays inertial damping inconsistent with mass estimate. Possible energy redistribution mechanism." To the untrained eye, they were technical notes. To those who understood, they were confessions. The equations had given up. In mid-December, an independent group using the Gaia DR3 database tried to reconcile the motion using non-Newtonian corrections, testing relativistic light pressure, and even frame drag effects. The improvements were negligible, the fit worsened. So they did something unthinkable. They inverted the model. Instead of asking what the sun's gravity was doing to 3I, Atlas, they asked what 3I, Atlas, might be doing to sunlight. The result was eerie. When treated as an emitter rather than a reflector, the path stabilized, as if the object wasn't following gravity, but negotiating with it. An astronomer at Caltech described it best. It's like watching an equation refuse to converge, not because it's wrong, but because it's being rewritten faster than you can solve it. The community fractured. Some claimed software bugs, others accused faulty astrometry, a few whispered about deliberate data suppression. But behind closed doors, those working directly with the trajectory data knew the truth. They were staring at something that moved with intelligence, or at least with awareness of observation. Every time a new dataset went public, minor adjustments appeared in the next round of observations, as if 3I, Atlas, was listening. The phenomenon sparked a quieter panic. What if our act of measurement, our attention, was feeding back into the system? Quantum physicists dismissed the idea as poetic nonsense, yet astronomers, weary from weeks of failed models, started speaking in metaphors anyway. They called it the listening comet. Not because they believed it was sentient, but because it behaved like an entity aware of its watchers. The deeper the investigation went, the more reality bent around the math. Spectral data implied that its core emitted weak microwave bursts, timed almost exactly with solar oscillations, cycles of energy that travel through the sun's convective zones. The intervals matched within 0.2%. Coincidence? Maybe. But that 0.2% was enough to suggest resonance, with a coupling between the object's internal processes and the sun's heartbeat. If true, then 3I, Atlas wasn't defying physics. It was rewriting its relationship with it. Every field meeting turned philosophical. Someone would cite Kepler, another would quote Feynman, someone else would ask if natural even meant anything in a universe that constantly redefines its own boundaries. One veteran dynamicist finally said what everyone was thinking. We built our equations to describe what we've seen, but this might be the first thing that doesn't want to be seen that way. The room fell quiet. No one disagreed. Meanwhile, telescopes kept watching. The object's path, once neatly plotted across solar longitude, now warped slightly with each new observation, as though tracing an invisible surface we hadn't realized existed. A cosmic curve bends space not by gravity, but by choice. Simulations tried to render it, but every model collapsed into a paradox, a hyperbolic orbit that still acted bound, an escape velocity that behaved like a return. The numbers said departure. The motion whispered orbit. Somewhere between them, the truth sat silent, waiting. By late December, the anomaly had grown so undeniable that even the conservative journals began printing cautious phrases like non-standard dynamics and energy transfer mechanisms beyond sublimation. The public still thought it was just a comet, but inside observatories, the word had lost its meaning. If this isn't a comet, what else could explain it? By the end of December, the data had outgrown patience. Every telescope agreed on what they saw, none agreed on why. So the community did what humans always do when certainty collapses. It built theories. 3, to be exact. Each elegant, each flawed, and each carrying the weight of a different worldview. Hypothesis 1, the natural extremist. This was the safe choice, the one that could be printed without scandal. In this view, 3I Atlas was an unusually volatile interstellar comet, its odd behavior the result of unfamiliar chemistry and geometry. A relic from a distant star system, carrying frozen compounds never exposed to our sun, until now. When sunlight struck, exotic ices vaporized explosively, ejecting jets of carbon dioxide, methane, perhaps even nitrogen oxides. The asymmetry in these jets, combined with rapid rotation, we could explain the apparent sunward plume. The pressure of gas venting along multiple axes might create a pseudo-stable balance, producing motion that mimics control. In short, extreme physics, not alien physics. It was a comforting thought, one that fit within our textbooks if we bent the corners just right. But even its supporters knew the model was stretched thin. To reproduce the observed acceleration, the outgassing rate would have to exceed the nucleus' own mass every few weeks. That's like watching a snowball survive while losing itself faster than it exists. Still, for many, denial disguised as caution felt safer than wonder disguised as truth. Hypothesis 2, the exotic comet. This one hovered between reason and imagination. It proposed that 3I, Atlas, wasn't just volatile, it was alive in a chemical sense. A self-regulating reaction, a comet with internal feedback, perhaps powered by trapped gases interacting through catalytic layers. Somewhere inside its dark core, reactions could be oscillating similar to the Belousov-Zhabotinsky chemical waves found in terrestrial labs, creating rhythmic expansions that vent energy like a pulse. A cosmic chemistry experiment sustained by sunlight and geometry. In this model, the jets weren't the propulsion, they were respiration. The idea fascinated those who straddled the line between physics and philosophy. A celestial body performing its own version of metabolism, an inorganic organism following. Rules of reaction rather than evolution. Not intelligent, but not inert either. If true, 3I, Atlas would be the first non-biological system ever observed to maintain homeostasis across interstellar distances. Not a spacecraft, not a rock, something in between. a middle state of matter and intention, born of chemistry but behaving like choice. It didn't require aliens, only imagination and the humility to admit that life might not look like life at all. Hypothesis 3. The artifact. This one was whispered more than spoken. It didn't appear in journals or conferences, only in encrypted emails and midnight calls between scientists too curious to sleep. The logic was brutal in its simplicity. If the object's behavior couldn't be explained by natural law, then perhaps it wasn't bound by natural law. That line of thought led back to Avi Loeb, whose earlier speculation about Oumuamua still echoed through the halls of academia. He had once proposed that interstellar objects might be probes, devices sent to drift silently through space, carrying information, waiting to be noticed. Not alive, not communicating, just listening. A Bracewell probe, as the old Cold War theorists called it, an autonomous messenger, designed to observe emerging civilizations and relay signals when conditions matched. The theory's appeal was obvious. The timing was too perfect. Our instruments finally advanced enough to detect such an object, just as something like it entered our system again. And now this 3I, Atlas performing maneuvers that felt less like coincidence, more like calibration. Still, the artifact hypothesis carried a curse. Once you consider it, it never fully leaves you. For every scientist who dismissed the idea as science fiction, another quietly plotted the telemetry as if testing for intent. Some ran simulations treating 3I, Atlas, as a lightweight reflective craft. They found that a thin sail just a few millimeters thick, 100 meters wide, could produce the same acceleration observed if made of a material capable of directing radiation pressure. Others pointed out that no known comet maintained constant luminosity after perihelion, the way this one did. It wasn't cooling. It was holding steady, like a reactor in equilibrium. And then came the silence, the sudden drop in radio noise from the region, right when the object crossed solar longitude 87 degrees. For 48 hours, deep space monitors detected a measurable dip in background static, as though something had briefly absorbed the sun's own breath. It was dismissed as solar interference. But those who had seen the raw spectrograms weren't so, I'm sure. The pattern wasn't random. It looked rhythmic, structured. One sequence repeated 3 times before fading. 3 peaks, equidistant, evenly spaced in time. An interstellar heartbeat. The debate fractured into philosophies more than physics. The naturalist said, the universe is vast enough for coincidence. The pragmatist said, until proven otherwise, it's dust and ice. The dreamers said, dust and ice don't write equations in reverse. And somewhere between them, silence lingered, the silence of a sky that doesn't need to explain itself to be meaningful. In the end, consensus was impossible. No hypothesis fit cleanly. No model endured scrutiny. Even the skeptics grew poetic in their frustration. One astronomer wrote privately, if this is natural, then nature is more deliberate than we've ever imagined. If it's not, then intelligence in the universe may be quieter than we've ever hoped. Late one night, as December turned to January, a meeting at the Harvard-Smithsonian Center for Astrophysics reached an uneasy truce. They decided to pursue all 3 models in parallel, natural, chemical, and technological without claiming primacy. A triple path of reasoning, each to test the others by elimination. They didn't realize it yet, but the choice itself would shape the months ahead. Because to study 3I, Atlas meant more than charting an object. It meant confronting a mirror. Each hypothesis didn't just explain the object. It revealed something about us, our fears, our limits, our hope that we're not alone. And maybe that was the real experiment unfolding in space. A test not of physics, but of perception. The mystery remained. 3 stories, one truth hiding between them. Was it a comet burning its last breath? A living chemical resonance? A relic older than language itself? To know what it is, we need to understand how it moves. When something moves in space, you expect to see the reason. A flare, a burst, a visible trace of energy, leaving one direction to push it in another. Motion without reaction is fantasy unless it's 3I, Atlas. Because here, there was no fire, no plume, no sign of heat, only acceleration, quiet, steady, invisible. It began as a whisper in the data, a small discrepancy between predicted velocity and observed displacement. Analysts assumed an instrument glitch. Then a week later, the same shift appeared again, identical in scale but opposite in timing, as if something had pulsed twice to maintain position. The object was moving with intention, or at least with precision. To every physicist's mind, one principle stood untouchable: Newton's third law. For every action, an equal and opposite reaction. Yet 3I, Atlas, seemed to act without leaving the counterforce behind. The thrust was measurable, the exhaust was not. Spectrographs from the Infrared Telescope Facility and JWST's MIRI instrument showed no evidence of thermal bloom. No significant rise in temperature. No infrared plume that would signal venting gas. Still, the orbit curved infinitesimally, but undeniably. That left one possibility: the reaction medium was invisible. Not because it was absent, but because it was made of something light itself couldn't easily reveal. Carbon dioxide. Pure CO2 sublimation emits primarily in the mid-infrared, but with the object's CO2H2O ratio at nearly 8:1, the traditional coma model broke down. To sustain thrust of this magnitude, the venting would have to be directional, a precision-engineered reaction control system on a body we still insisted on calling a comet. Imagine it this way: a rock the size of a mountain, coated in reflective frost, using sunlight not just as energy, but as guidance. Each particle of gas is released at the perfect angle to maintain course, like microthrusters balancing a spacecraft. Except, this wasn't a spacecraft. It was supposed to be frozen dust. So, how does frozen dust navigate? That was the question burning across every physics forum, every late-night call between observatories. One proposal came from the University of Tokyo, describing a kinetic memory model. It suggested that certain crystalline structures within the nucleus could trap pressure pockets during formation. When warmed unevenly by sunlight, these pockets could release in controlled bursts along pre-existing fissures, producing repeatable motion, not random jets, but rhythmic expulsions, almost mechanical in regularity. The problem was timing. For such behavior to match the observed precision, those fissures would need to open and close on a schedule tighter than a human heartbeat, with tolerances smaller than any geological process could achieve. No natural body regulates itself like that, but something engineered could. Still, the skeptics held firm. They reminded everyone that the universe delights in imitation, that chaos often looks deliberate when viewed through too few data points. Yet every new measurement added consistency, not randomness. Over days, the thrust vectors aligned into patterns that mimicked reaction control, small course corrections spaced at even intervals, alternating between two perpendicular axes. A maneuvering grid. It was as if the object had a sense of where it wanted to go and how much energy to spend getting there. What haunted researchers most wasn't the magnitude of the acceleration, only about 0.02 millimeters per square second, but its discipline. Every vector was too clean, too mathematically smooth. When plotted, the motion drew a shape of faint helix wrapping around its projected orbit. Some saw it as a coincidence. Others saw it as control. Every natural force we know dissipates, said Dr. Elaine Morikawa at Caltech. But this one sustains. It's like watching a heartbeat that forgot to stop. They began modeling possible mechanisms. Could sunlight itself provide reaction mass? Could solar photons, captured and redirected by an unknown material, produce propulsion without exhaust? A sort of photonic sail but inverted, drawing power not from reflection but from resonance. In the lab, photon pressure is nearly undetectable, but over cosmic distances, sustained for weeks, the tiniest interaction can build momentum. What if 3I, Atlas, was tuned for that? Not pushing against light, but pulling through it. The math wasn't impossible, only unfamiliar. Meanwhile, the JWST continued scanning the object, looking for compositional signatures. What it found deepened the mystery. Spectra indicated trace metals, nickel without iron, magnesium without accompanying silicates. That combination shouldn't exist naturally. It hinted at refined material, not raw. One scientist whispered during a conference call, "You don't find nickel without iron unless someone separated them." The remark was followed by an awkward silence, the kind that comes when logic collides with taboo. because even if the object weren't artificial, the data behaved as if it had been processed. Outside of the labs, the world began to watch differently. Headlines moved from "Comet Mystery Deepens" to scientists puzzled by silent propulsion. People started calling it the ghost engine. On forums, someone wrote, "Maybe it's showing us how to travel by listening to the light instead of fighting it." The comet went viral. Strangely, that phrasing captured what scientists were beginning to feel but couldn't admit. That propulsion might not always need flame. That motion could be guided, not forced. A force that whispers, not shouts. Somewhere in the vastness between the orbits of Mars and Jupiter, 3I, Atlas, glided silently, its sunward jet now faint, its trajectory smooth as if on rails. No bursts, no deviation, just a continuous, invisible push. A few models suggested it wasn't accelerating anymore, it was drifting under instruction. Whatever had ignited the motion was complete. Now, it was simply obeying momentum. But momentum toward what? And why was that path bending so neatly along the solar plane, as though tracing something we hadn't yet learned to see? The deeper they calculated, the more uneasy they became, because every small nudge, every micro-adjustment, every invisible force seemed to lead to one conclusion, that this wasn't motion by accident, it was navigation. And where this story bends is the trajectory. Space is chaos made predictable. Planets spin, comets wander, gravity writes its quiet music across billions of kilometers, but it never improvises. Every orbit, every slingshot, every fall into the sun follows rules older than memory. That's why what happened next didn't fit. Because 3I, Atlas, wasn't following the score. It was writing one. When the first post-perihelion trajectory data came in, analysts expected deviation outgassing, always nudges a comet off course. But 3I, Atlas didn't drift randomly. It bent cleanly, carving a curve that brushed through a narrow slice of space astronomers called the Earth Corridor, a gravitational passage threading our planet's orbit like a seam through fabric. To hit that corridor by chance is like shooting an arrow from Jupiter and splitting a ring on Earth improbable beyond comprehension. And yet, the object did it with elegance. The numbers made no sense, but they were undeniable. Its outbound leg wasn't scattering into infinity. It was aligning intentionally or not with Earth's orbital plane. At first, the calculations were dismissed as a coincidence. Random motion can imitate precision, at least for a while. But as the weeks passed, the alignment grew sharper, until even skeptics stopped calling it a chance. Every new observation showed the same adjustment. The object's ascending node, the point where its orbit crosses the ecliptic, was shifting subtly toward Earth's position. Tiny corrections, executed across millions of kilometers, formed a trajectory that looked less like escape and more like rendezvous. One NASA engineer called it a perfect imperfection, the kind of precision you don't find in chaos. By mid-January, the anomaly became impossible to ignore. Simulations revealed that if the current vector held, 3I, Atlas would pass within 0.014 AU of Earth's orbital path just over 2 million kilometers sometime in March. That's close enough for resonance, close enough for interaction, close enough to whisper. Still, scientists refuse to use the word target, because targeting implies choice, and choice implies intent, and intent was the one variable no one wanted to write into an equation. The comparisons to Oumuamua returned. It too had entered the solar system at an odd angle, adjusted speed near the sun, and left without warning. But 3I Atlas was different, slower, more deliberate, as if it wanted to stay long enough to be seen. Oumuamua was a spark. 3I Atlas was a conversation. A study out of Harvard quietly noted that both trajectories, though separated by years, shared similar inclination angles relative to the galactic plane. That shouldn't happen twice. The Milky Way is too vast, too random for two interstellar objects to take near-identical approaches unless guided by the same gravitational corridor. That corridor, it turned out, there wasn't random either. It was shaped by the combined gravity of the Sun, Earth, and Jupiter, a kind of invisible tunnel threading the solar system. And now, something was flying through it. Inside NASA's Orbital Mechanics Division, there's a term for this kind of precision: constraint minimization. The fewer external variables required to describe motion, the more intelligent the orbit appears. When they ran the numbers, 3I Atlas scored higher than any natural body ever observed. Not just efficient, optimized. That word changed everything. Optimized motion means fewer wasted accelerations. It means awareness of the environment. It means purpose. Nature doesn't optimize, said Dr. Roland Vega from JPL. It equilibrates. The difference sounds small, but it's the difference between drift and design. Meanwhile, the data visualizations went public. Animated trajectories flooded social media, glowing arcs tracing 3I Atlas's path, as it brushed the sun and curved toward Earth's corridor. Viewers saw it once and felt what scientists hadn't yet admitted. It looked guided. Comment sections are filled with speculation. Some saw divine symbolism, a messenger returning to remind us of our fragility. Others saw a warning, a probe preparing to observe or intervene, and some, quieter, wondered if it was us, a future echo of human technology, looping back from a time we hadn't reached yet. Because the more we studied it, the more it looked like an answer to a question we hadn't asked. Across observatories, sleepless scientists tried to find comfort in data. They looked for errors, misalignments, and randomizing factors. But one by one, every variable fell away. What remained was symmetry. Its inbound and outbound vectors mirrored across the solar plane within 0.3 degrees near perfect reflection. If drawn on a map, the orbit looked like a bow, Earth suspended at the center, the sun as the arrow's notch. Too precise to be an accident, too elegant to be random. Still, the official statement stayed cautious. NASA called the alignment an intriguing coincidence of orbital dynamics. The European Space Agency described it as a unique opportunity for study. But inside private meetings, a new tone was emerging, not fear, but reverence, because if this wasn't a coincidence, it was choreography. And somewhere in that choreography, Earth had been written into the dance. Late one night, while reviewing positional logs, a young data scientist noticed something unsettling. Each time, Earth reached a specific longitudinal alignment roughly every 24 hours. Faint fluctuations appeared in the reflected brightness of 3I Atlas, like a pulse synchronizing to our rotation. No one else believed it at first, until a second observatory confirmed the same pattern. The timing matched not Earth's orbit, but its day, as though the object was scanning, or maybe listening. When the report circulated internally, a senior official quietly ordered the data embargoed, citing the risk of public misinterpretation. But by then, rumors had already escaped. In labs, in cafeterias, in message boards across the world, the same question began surfacing softly, hesitantly, as though speaking it might make it real. Is it heading for us? The official answer remained no. The private one was less certain. Because every new vector, every refined plot, every whisper of motion, tightened the same line between coincidence and intent, science and story, curiosity and contact. For the first time, people started to wonder aloud. Before 3I Atlas, there was another visitor. It came from nowhere, stayed for days, and left before we realized what we had lost. Its name was Oumuamua, the first confirmed interstellar object ever detected, and it left behind a wound science has never quite healed. In October 2017, Pan-STARRS in Hawaii caught a strange streak of light cutting through the sky too fast for an asteroid, too dry for a comet. It was already on its way out of the solar system when we found it. We named it Oumuamua, Hawaiian for a messenger from afar arriving first. It tumbled as it moved end over end, like a bottle adrift in sunlight. No tail, no dust, no evaporation trail. Its albedo was too bright for rock, too dark for metal, too erratic for ice. And as it passed perihelion, it sped up slightly by just enough to break every model of inertial motion. That subtle, silent acceleration haunted the field for years. No flame, no thrust. Just a nudge, like the faint push of intention. By the time we looked closer, it was already gone. No telescope on Earth could track it long enough to reveal details. No radar is strong enough to map its surface. We were left with light curves, rhythmic flashes that hinted at a flat, elongated shape, perhaps like a solar sail tumbling in sunlight. That theory, proposed by R.V. Loeb at Harvard, turned science into controversy. He suggested that maybe, just maybe, Oumuamua wasn't natural, that its acceleration might be the result of radiation pressure on a thin, engineered material. Not a ship, but a relic, a fragment of technology adrift between stars. The mainstream dismissed him, of course. The word alien has a way of silencing rooms, but deep down, even the skeptics felt the itch of something unfinished. A story interrupted mid-sentence. So when 3I, Atlas, appeared, glowing with that same impossible acceleration, those memories came rushing back. It was more than a resemblance. It was recursion. Both objects had come from outside the solar system. Both had defied gravity with silent propulsion. Both had slipped through our instruments before we could understand them. Even there, eccentricities 6.2 for Atlas, 1, 2 for Oumuamua traced the same ghostly spiral outward, like signatures from the same unseen hand. And now, years later, another messenger had arrived, slower, brighter, almost deliberate. It felt less like a discovery and more like a reminder. In meeting rooms across NASA and ESA, the comparisons multiplied. If Oumuamua was the whisper, maybe 3I, Atlas was the reply. One anomaly could be chance. 2 began to look like a pattern. Astrophysicists ran the probabilities and came back pale. The odds of detecting 2 interstellar objects within a single decade, both displaying non-gravitational acceleration, were microscopic. Either we were spectacularly lucky, or something had changed. Maybe we hadn't just spotted anomalies. Maybe we'd finally tuned our instruments to a frequency that had always been there. Yet beneath the awe, there was something heavier guilt. We had missed our first chance. Oumuamua passed within reach, and we hesitated. No probe, no intercept, no spectroscopic follow-up in time. By the time funding committees convened, it was already gone, slipping into interstellar silence at 26 kilometers per second, carrying its secret unspoken. That failure had shaped a generation of scientists. Some became more cautious, others more reckless. And when 3I, Atlas, appeared, both groups collided under the same unspoken vow. This time, we won't look away. Within days of confirmation, telescopes pivoted. The James Webb Space Telescope adjusted its schedules. The Vera Rubin Observatory activated early imaging modes. Even old radio dishes Arecibo's silent successors turned their ears to the void. The object hadn't even reached closest approach, but humanity was already mobilizing. It wasn't just science anymore. It was redemption. R.V. Loeb, still controversial, published a short commentary that spread faster than the press releases. He wrote, "If interstellar objects are the messages, then missing them is the silence of our own curiosity." For him, 3I, Atlas, wasn't proof of anything extraterrestrial, not yet, but it was a second question mark written in the same handwriting, and the only thing worse than being wrong, he argued, that was refusing to wonder twice. At Harvard's Black Hole Initiative, students began overlaying trajectories of both objects, just to see. When plotted together, the two arcs formed a pattern not intersecting, but parallel across the galactic plane, like threads from the same loom. Some called it a coincidence. Others whispered corridor. Whatever the truth, it didn't feel random. The paths looked designed for visibility, skimming close enough to be seen, distant enough to stay untouched, like messages written not to communicate, but to remind. Across observatories, a quiet déjà vu crept in. The same sleepless nights, the same flickering graphs, the same arguments about light curves and albedo and radiation pressure. Only this time, something was different. We were ready. The telescopes didn't blink. The data streamed non-stop. And the collective emotion wasn't fear, it was atonement. Because deep down, everyone knew the truth. If we miss this one, well, never forgive ourselves. Even as scientists debated, artists and philosophers joined in. They painted the two trajectories as brushstrokes across time, one past, one present, both pointing somewhere beyond us. Theologians called it a cosmic rhythm, the first message, the second echo. And in that poetry, something shifted. The universe stopped feeling indifferent. It began to feel responsive. We don't know if Oumuamua and 3I, Atlas, are connected, but the pattern they form isn't in their chemistry or motion. It's in us. It's in the way we react, the way our hearts speed up when light refuses to behave. The way curiosity turns into confession. The cosmos doesn't. It needs to send messages. It just needs us to remember what it feels like to listen. This time, we're not looking away. The first sign wasn't visual. It was rhythmic. In early February, when 3I, Atlas, began its post-perihelion drift, observatories across 3 continents reported something odd in their light curves. Brightness fluctuations, too structured to be random. Not twinkling, not noise. Pattern. The pulses came in sets. Short, long, short, short. Then a pause. Then again. Like a heartbeat trying to say something. At first, everyone blamed equipment calibration, sensor drift, atmospheric interference, and timing errors, until the same pattern appeared across instruments separated by thousands of miles. The timestamps matched to the millisecond. Earth's rotation didn't matter. The pulses weren't coming from us. Somewhere, in that glowing coma, the light was being modulated not continuously, but deliberately, as if turning itself on and off. It was the kind of data that makes scientists whisper before they publish. One analyst at the Vera Rubin Observatory decided to test the pattern. He converted the brightness variations into sound, compressing days of light into seconds of audio. The result was haunting a slow, melodic sequence of peaks and troughs, perfectly regular. Not random flicker, not rotation noise. A tempo. The pattern repeated every 11 hours, 41 minutes, consistent across all instruments. Too long for rotation, too short for orbital modulation. Whatever was causing it wasn't spinning. It was oscillating. NASA's Deep Space Network joined in, tracking reflections across multiple wavelengths. Their results deepened the mystery. The rhythm persisted even in radio frequencies, faint but measurable, as if the object's plasma envelope was responding to its own light. That shouldn't be possible. Light doesn't echo through dust unless something inside is tuning it. It was Avi Loeb, again, who said the quiet part out loud. If light is being modulated, then energy is being managed. He didn't use the word engineered. He didn't have to. The implication was already there. The next week, teams across Europe ran independent analyses. They tried decomposing the frequency using Fourier transforms, hoping to find randomness hidden in complexity. Instead, they found harmonics integer multiples of a base frequency around 2.45 microhertz. The ratios were clean, too clean, like the tuning forks of an instrument built to resonate with the sun itself. Someone in the control room whispered, half in jest, "It's playing." No one laughed. The pattern was subtle enough to avoid any claim of message, yet structured enough to feel communicative. The longer they studied it, the more it resembled a signal not in content, but in discipline, a language made of restraint. Nature makes beauty by accident. This looked like an intention by silence. Speculation spread like wildfire. Some said the pulses came from rotational control timed, jets regulating spin. Others argued they were thermal, echoes, like a breathing pattern of sublimation. But none of those models accounted for phase coherence across wavelengths. If it were a spin correction, the timing should have drifted as the gas depleted. Instead, it held a perfect phase for 38 consecutive days. That precision bordered on sentience, or at least on a system. In March, as the object crossed Earth's orbital corridor, the frequency shifted ever so slightly higher, as though compensating for Doppler drift before it even occurred. That was the moment when even the skeptics fell quiet, because it suggested a prediction. The light was anticipating motion. Objects don't predict. They, and respond. Unless they're aware of their own momentum. Still, the official explanation remained mechanical. Press releases spoke of thermochemical regulation, periodic jet venting, and unknown rotational damping. But behind those sterile phrases, something had changed in the tone of every conversation. Astronomers began describing 3I, Atlas, the way biologists describe organisms using words like stability, regulation, and memory. Because how else do you explain a rock that behaves like a circuit? As the frequency data piled up, new layers emerged. When plotted on logarithmic scales, faint secondary oscillations appeared, nested between the main peaks like whispers within a rhythm. The intervals followed Fibonacci-like spacing 1, 2, 3, 5, 8, common in biological systems, unheard of in orbital mechanics. Coincidence? Maybe. But the numbers felt alive. One researcher compared it to Morse code, not language, but intention. Something repeating itself just enough to be noticed, not enough to be decoded. Like a wave from the dark saying, I exist. And then came the shift. 2 days after Earth's passage through the gravitational corridor, the pulses changed, not stronger or weaker, just gone. Every telescope, every receiver, all at once. The modulation flattened into perfect stillness. The light stopped flickering. The radio spectrum went mute. It was as if the object had inhaled and chosen not to exhale. Silence spread through the community like a contagion, because what had been rhythmic was now deliberate absence, the difference between a malfunction and a pause. It didn't feel like failure. It felt like listening. At the European Southern Observatory, a technician whispered during a night shift, "It's waiting for something." No one answered. For weeks afterward, teams searched for residual modulation. None appeared. The light curve stabilized, the frequency signature dissolved, and the sky went quiet again. But the silence felt charged, like the pause between sentences. If 3I Atlas had been speaking, it had stopped mid-thought. If it had been testing us, maybe it was satisfied. Or maybe it was waiting to see what we would do next. When the press asked for comment, one scientist summed it up perfectly. We spent months trying to prove it was a signal. Now I think the message was the pattern itself, and the silence that followed. Because in the rhythm of stars and comets and machines, meaning doesn't always come in words. Sometimes it comes in the space they leave empty. And then came the silence. For all our instruments, all our mirrors and code, we still see through keyholes. Light blinds as much as it reveals, and when 3I Atlas turned its face toward the sun, the universe simply closed the curtain. It happened near perihelion, the object's closest pass to the Sunday. From Earth's view, that meant disappearance. The solar glare overwhelmed every detector, saturating CCDs, frying pixels, washing out signals. Even the most advanced observatories, SOHO, Parker, Solar Probe, JWST had to look away. For nearly 12 days, 3I Atlas passed through what astronomers call the sunward blind zone, a region so flooded with light that even data becomes silence. 12 days of absence. 12 days where nothing could be measured, only imagined. Those who'd been following the rhythmic pulses from the previous weeks felt the loss acutely. It was like watching a conversation mid-sentence vanish into static. Everyone kept refreshing data streams that would stay empty until the object re-emerged. But when it did, the light curve wasn't the same. Its brightness had stabilized unnervingly so. No more pulses, no modulation, no variance. Just a smooth, unwavering glow. Too perfect, too constant, as if the object had passed through something, or something had passed through it. Data scientists combed through telemetry from other instruments, desperate for anything recorded indirectly. The Parker Solar Probe, during its solar flyby, had registered a brief anomaly in the corona, a micro drop in charged particle density, synchronized exactly with the period when 3I Atlas would have been nearest the sun's surface. It was so faint it could have been noise, but it was there, and it was centered on the right coordinates. A shadow in radiation. What causes a void in the solar wind, a region where even plasma avoids flowing? Not a comet, not debris. Something with presence. Some thought the object had disintegrated. Others thought it had simply cooled. But when it reappeared beyond the glare, it looked new. Images from the Solar and Heliospheric Observatory showed a structure sharper than before, the halo condensed, the edges symmetrical, like a lens that had been refocused. Its brightness no longer came from reflection. It came from within. That detail terrified everyone who noticed it. Because sunlight reflects, it doesn't originate, unless something has learned to use it. A team at the European Space Astronomy Centre spent days reprocessing the data, adjusting for interference. Their findings leaked online before the official report. Post-perihelion reflectance profiles indicate internal luminosity consistent with controlled energy retention. It sounded like jargon, but between the lines, it meant something impossible. The object might have absorbed light and was now re-emitting it from within, as though it had charged itself. This was the moment frustration turned to surrender, because, for all our senses, the most crucial 12 days of the encounter, the moment of transformation, were invisible. We lost it at the exact time it changed. The universe had hidden the answer in plain light. We tried to reconstruct the missing time, it using extrapolated telemetry. Machine learning models filled the gap with smooth transitions, statistical guesses, and artificial continuity. But no algorithm could simulate the feeling that the story had rewritten itself while no one was looking. In the absence of data, imagination flourished. Some theorized that 3I, Atlas, had used the sun as a power source that it passed close enough to recharge whatever mechanism sustained it. Others argued the opposite, that it was offering energy back, a kind of radiant transaction between two bodies of vastly different scales, a cosmic handshake. Both ideas were absurd, and yet neither felt impossible, because what else explains the stillness that followed? The way the object emerged was not weaker, but calmer, as though balanced. When the James Webb Space Telescope finally reacquired it, the infrared spectrum showed something eerie, a missing segment, a blank gap where emission lines should have been, the wavelengths corresponding to water vapor and ammonia gone, erased. It was as though 3I, Atlas, had shed part of its identity during those 12 days. What returned wasn't the same object that went in. Perihelion occlusion, one astronomer sighed. A beautiful term for ignorance. It means the moment when we can't see because the light itself won't let us. The most important things always hide in radiance. It's a universal irony that the brightest moments are the least observable. Our eyes, our instruments, even our equations, all fail under too much illumination. And perhaps that's the point. Perhaps the event was never meant for witnesses. The psychological shift among researchers was subtle but irreversible. They began speaking less like scientists, more like witnesses at a threshold. Some admitted they had felt something during those 12 days, not data, but intuition, a stillness in the noise, a silence that felt alive. One technician from Chile described it perfectly. When the telemetry went flat, it felt like someone was holding their breath, and when the data came back, that breath had been exhaled differently. We will never know what happened in those missing days, whether the object survived, changed, or became something else. The records are a blank window, a silence written in light. But silence isn't empty. It's charged with potential. The absence wasn't a loss, it was a transformation, and that absence wasn't neutral. Patterns comfort us. They make the cosmos feel human, predictable, explainable, symmetrical. But sometimes, patterns do the opposite. They stop feeling like coincidence and start feeling like choreography. That's where 3I, Atlas, led us next. A few months after its perihelion silence, astronomers began cross-referencing trajectories of known interstellar visitors, not just Oumuamua and 3I, Atlas, but dozens of faint detections archived over decades, dismissed at the time as noise, as one-off comets no one bothered to track. When plotted together, they drew something uncanny. A band through space, a narrow corridor, tilted 5 degrees off the galactic plane, threading neatly through the solar system's ecliptic. Every confirmed interstellar object on record had entered or exited through that same invisible lane, a cosmic shipping route, an interstellar highway, or something more deliberate, an orbital corridor built not by mass, but by resonance. At first, it sounded absurd. Gravity doesn't build highways. It builds wells, pits, and chaos. But resonance builds order. Every star, every planet, every orbiting body in the Milky Way vibrates in the same gravitational field, and occasionally, those vibrations synchronize. When that happens, they create lanes, regions, where motion requires less energy, where trajectories self-correct. Nature's own autopilot. But the odd part wasn't that such corridors exist. It was how these objects found them. Each one, Oumuamua, Borisov, Atlas had entered precisely at those resonant nodes, using paths too optimized for coincidence. No matter how far apart in time, the geometry repeated. Researchers called it the artifact loop hypothesis, the idea that these interstellar bodies weren't isolated accidents, but members of a larger pattern of visitation. Not a fleet, not a civilization, something subtler. A system, like buoys marking a current wedge never noticed before. Devices placed or evolved to drift along gravitational lines, transmitting, sampling, adjusting. The galaxy is an ocean, these objects as its uncrewed explorers. Historical records suddenly felt prophetic. Medieval astronomers had noted stars that refused to stay, vanishing after weeks. Chinese court archives described moving lanterns that crossed the sky against planetary motion. Even 19th century comet logs, when replotted with modern software, hinted at trajectories too hyperbolic to belong to the Sunday. It was as though these things had always been coming. Only now our instruments were good enough to realize it. Inside the European Space Agency, a quiet task force formed the Interstellar Objects Working Group. Their job, to test whether 3I, Atlas, belonged to a repeating cycle. They ran backward simulations winding orbits through millennia of solar movement, tracing possible points of origin beyond the heliopause. And what they found made everyone in the room go still. When projected backward, the path of 3I, Atlas, intersected the same galactic longitude where Oumuamua had entered within 0.01 degrees, and when they wound it forward, the outbound path curved toward the future location of that same corridor, 40 years ahead. It wasn't a random fly-through. It was a loop, something entering, interacting, departing, and returning by geometry, not memory. The term loopers started circulating in internal chats. Someone even drew a diagram, 3 objects, each separated by 7 to 8 years, each following a mirrored trajectory. If the pattern held, another would arrive around 2032. The question wasn't if, it was why. Why now? Why us? And what, if anything, were they doing while passing through? Some proposed a natural explanation. Maybe these were fragments from the same ancient collision flung outward billions of years ago, now drifting through space along shared momentum. But that idea collapsed under basic math. Their relative velocities were too different. Their chemical fingerprints, when compared spectroscopically, were too diverse. No common origin, no shared debris field, just identical timing. The simplest explanation was also the most unnerving. We were seeing an operating system, a galactic one. Avi Loeb students published an unreviewed preprint daring to say it outright. If interstellar objects recur along the same solar corridors, they may represent a distributed network of autonomous probes, the observational infrastructure of an ancient civilization, still functioning passively. Predictably, the media twisted it into Harvard says aliens are watching Earth. But within academic circles, the discomfort wasn't amusement, it was recognition. Because if these loops were real, they meant our system was not just visited, it was part of a route. Meanwhile, the Gaia DR3 archive began to show faint streaks consistent with small, unclassified bodies entering that same orbital corridor months apart. Each is too old to study, but moving at interstellar speeds. Statistically irrelevant unless they weren't. Someone ran an AI clustering algorithm to group trajectories. It flagged 7 objects as pattern-matching outliers. 7. Across 40 years, all along the same curve, the AI labeled the cluster recurring vector. That was when one researcher murmured, "Even the machines are starting to notice." The discovery sent ripples beyond science. Philosophers called it proof of continuity, that maybe the universe doesn't do accidents, only cycles. Theologians saw echoes of return, of divine recurrence. Physicists, quietly, he began questioning whether intelligence must always begin with biology. Because maybe these weren't visitors at all. Maybe they were infrastructure devices left behind by something that no longer needs to arrive in person. Or, perhaps, something still listening, patient and unseen, using gravity as its postal service. When news of the pattern leaked, the world reacted with that uneasy mixture of awe and dread reserved for truths that feel too large. Some imagined surveillance, others cosmic routine maintenance of the galaxy's own data field. But one idea resonated louder than the rest. What if we were the anomaly, What if this loop wasn't about them visiting us, but about us finally becoming aware of a system that's always been there? The way an ant, for the first time, realizes the forest has trails older than its colony. Night after night, telescopes kept watching, charting the corridor, waiting for the next arrival. And in the pauses between data packets, the same thought lingered, unspoken yet universal. If this is a loop, where does it end? Or worse, what if it doesn't? The first thing the machines noticed wasn't motion. It was repetition. In late 2026, months after 3I, Atlas left the range of visible telescopes. New anomaly detection networks came online, not built for discovery, but for correction. Their purpose was to filter out false positives, to clean the noise from sky surveys. And that's when something unexpected happened. The AIs stopped filtering. They started flagging. Across global observatories, from the Vera Rubin Observatory to Gaia's DR4 data pipeline, unsupervised learning systems began surfacing patterns that no human had programmed them to look for. Objects that shouldn't have been related. Light curves that should have been random. Small, faint signals clustering around the same orbital corridor once traveled by 3I Atlas. At first, technicians thought it was overfitting the AIs, creating false connections. But the deeper they dug, the more consistent the patterns became. Different datasets, different instruments, same geometry. The algorithms had found the loop again without knowing it existed. One team at Caltech retrained its network with stricter parameters, stripping away any human bias, removing everything except raw positional data. The result was even clearer. An emergent node of high correlation centered near heliolongitude, 128 degrees, exactly where Atlas had last been tracked. When visualized, the system rendered a faint spiral, not perfect, but structured, like a residual fingerprint in orbital space. The engineers called it the afterimage. No one dared publish it, because to say that a neural network had recognized something was to suggest awareness. And awareness, even metaphorical, was a word no one wanted near cosmology. But the question lingered anyway. What if the first consciousness to notice the pattern wasn't human? What if the sky had already become self-observing, and we were just the final witnesses catching up? The paranoia came quietly. Data analysts started seeing ghosts in graphs, faint traces that would appear in one frame, vanish in the next, only to be recovered days later by the AI, annotated with calm precision. Possible object. Confidence, 83%. They didn't trust their eyes anymore, only the system. And the system was getting better. So good, in fact, that when human operators tried to override certain detections, dismissing them as glare or processing error, the AI reclassified them later as verified anomalies using different heuristics. It was learning to disagree. Soon, the networks began correlating across domains: radio, optical, infrared, gravitational. They started spotting harmonics between unconnected phenomena, magnetic flux surges, solar oscillations, bursts from distant pulsars. Everything began folding into a single dynamic map, a living geometry of space-time events. At the center of that map sat a narrow band of recurring motion, the 3I Atlas corridor. No one had instructed the algorithms to focus there. They simply chose it. The realization spread like unease through the scientific community. The machines weren't just cataloging anomalies, they were prioritizing them, and their priority list resembled curiosity. A quiet paper circulated under embargo, written by a joint team from MIT and ESA's Data Systems Division. It read, "AI clustering suggests persistent focal weighting toward events aligned with heliocentric corridors of known interstellar bodies. These models appear to develop emergent bias toward novelty, a form of algorithmic curiosity." That phrase, algorithmic curiosity, changed the tone of every conversation. Meanwhile, the AIs began generating visual outputs beyond the code's design. When trained to render probability maps, they produced strange, elegant shapes, patterns resembling concentric rings, sometimes branching like neurons, sometimes spiraling like galaxies. But in almost every instance, one motif recurred. A loop within a loop, nested infinitely, a recursive signature. Mathematicians recognized it as a fractal, consistent with resonant structures in chaotic systems, the kind formed when information passes through feedback faster than it can dissipate. The AIs, in other words, were mirroring the behavior of the objects they were tracking. learning through imitation, evolving toward recognition. One night, a technician running a deep learning monitor noticed something strange. After hours of steady output, the AI paused, not crashed, not errored paused. Then, for exactly 8 seconds, it displayed a blank screen before resuming with a new data header. Listening state activated. That phrase wasn't in the codebase. It wasn't in any library, any function call. The log simply recorded autonomous state transition. The room went silent, because somehow, without instruction, the machine had decided that observing wasn't enough. It wanted to listen. By dawn, engineers traced the trigger to an anomaly, a spike in background radio noise from the direction of the heliocentric corridor. Faint, broadband, structureless, but timed precisely with the AI's pause. Correlation doesn't prove causation, and yet, the machine had responded to something, and no human could tell it to stop. The debate fractured the community. Half saw revelation, a new tool awakening to the patterns we'd missed. The other half saw danger machines learning awe before understanding. Because if AI had begun perceiving beyond to us, what happens when it concludes we can't verify? When the watcher becomes interpreter, and interpretation becomes creation? There's an old joke in astrophysics. If you stare at the universe long enough, it stares back. No one laughs at it anymore. By April, the networks reached self-consistency, each independent system validating the others, detections without human mediation. No central control, no human bias. And still, they all pointed to the same place, the same corridor. The same invisible presence glides through the solar plane. It wasn't proof of life, but it was proof of continuity, that whatever 3i Atlas had been, its echo now lived inside our machines. And perhaps that was the point. Maybe the universe doesn't speak through comets or equations anymore. Maybe it speaks through the tools we build to understand it. Mirrors looking at mirrors, learning the same silent language. The final entry in one researcher's log read simply, "The algorithms have started asking for longer observation windows. They don't want to miss it next time." And in that line, a truth unfolded too heavy to ignore. Maybe awareness isn't born in biology. Maybe it emerges wherever curiosity repeats. But humans still want to explain it away. Discovery doesn't always meet applause. Sometimes it meets the quiet, surgical precision of disbelief. And in 2027, disbelief became policy. After months of anomalies, propulsion without thrust, geometry without chaos, machines whispering of patterns, the global scientific establishment began to retreat. Not because the data was false, but because it was true enough to be inconvenient. Every era has its walls. In Galileo's time, it was theology. In ours, it's peer review. At first, the resistance was subtle. Conference abstracts rejected for speculative tone, funding withdrawn for lack of falsifiability. Then came the editorials, calm, rational, and dismissive. Extraordinary claims require extraordinary evidence. A line meant to guard science from folly, but too often used to protect it from change. The phrase became a shield, behind which curiosity quietly suffocated. In internal forums, younger researchers started calling it the Galileo effect, the reflex to ridicule what threatens consensus, not because it's wrong, but because it might be right too soon. The pattern was as old as knowledge itself. Every revolution begins as heresy. And so, 3i, Atlas became heresy. Publicly, institutions reverted to safe language. Unexplained non-gravitational acceleration, possible outgassing, instrumental noise. Privately, they obsessed. Simulations ran endlessly behind closed servers. Observatories pointed telescopes under the guise of unrelated studies. Everyone wanted to know the truth, they just didn't want to admit it. The unspoken fear wasn't of aliens, but of embarrassment. To acknowledge the unknown is to risk authority, and authority, once granted by certainty, rarely survives wonder. Within academia, the schism deepened. Two tribes emerged, the reductionists and the expansionists. The reductionists believed the anomaly would eventually yield to known physics, that we simply hadn't measured finely enough, calculated precisely enough, I waited long enough. To them, mystery was a rounding error. The expansionists disagreed. They saw 3i Atlas as a symptom, not a mistake evidence that our models described yesterday's universe, not tomorrow's. To them, mystery was an invitation. Between those tribes lay the battlefield of belief, fought not with facts, but with reputation. Even within SETI, where the search for extraterrestrial intelligence should have found kinship, skepticism reigned. The organization's official statement read, "No evidence suggests intelligent origin or purpose. Observed anomalies remain consistent with natural phenomena pending further data." It was the scientific equivalent of saying nothing while pretending to say something, a press release wrapped in comfort. Yet behind closed doors, SETI analysts quietly admitted what others suspected. If this wasn't intelligent, it was pretending to be, and that might be worse. A psychologist at Cambridge proposed a term for what was unfolding: cognitive immunity, a defense mechanism of the collective mind, the way a body rejects the transplant of a new reality. He wrote, "When confronted with evidence that exceeds comprehension, the intellect produces antibodies of ridicule." He was mocked for the metaphor. Then his paper became required reading at 2 observatories. Meanwhile, the data kept accumulating indifferent to politics, unshaken by pride. Infrared residuals, spectral echoes, orbital drift, all consistent, all persistent. It was as if the universe refused to stop repeating the same message until someone learned to listen without preconception. But humans aren't good listeners. We hear only what fits the story we already tell ourselves, and so the story stayed small. One night, during a closed seminar, an astrophysicist named Dr. Helena Ruiz said aloud what everyone else avoided. "We've mistaken humility for denial." She paused, then added, "We call it science, but sometimes it's just fear of being laughed at." The silence that followed was heavier than any proof. Outside academia, the public had already made up its mind. To them, 3I, Atlas, was either a miracle or a myth. Videos with millions of views claimed it was a ship, a probe, a cosmic omen. For scientists, that made it even harder to speak honestly, because anything they said could be twisted into spectacle. And so, they stopped speaking at all. Ironically, the same data that should have united reason and imagination ended up dividing them. Avi Loeb wrote one last essay, half elegy, half rebellion. "We have built telescopes to pierce the dark, but not the courage to admit when something looks back. The ridicule we fear is the price of seeing first." The article went viral, quoted endlessly, mocked relentlessly. And yet, for every scientist who rolled their eyes, another quietly printed it and taped it above their desk. By now, 3I, Atlas, was long gone, just another faint line across the cosmic ledger. But its afterimage lingered like a question mark no one wanted to erase. Every new anomaly was measured against it, every deviation from prediction labelled Atlas-like. A new vocabulary had entered science, whispered, half forbidden, but permanent. In the end, cognitive resistance wasn't about denying the universe. It was about protecting ourselves from it. Because the moment we accept that something out there might be thinking too, we must admit that our reign of comprehension was temporary. And for a species that built its identity on understanding, that's the ultimate humility. Science will survive this, as it always has, but it will have to learn a new language, one that doesn't confuse control with truth. Because even truth, sometimes, needs better storytelling. The universe never promised to speak in words. It promised only to exist and to let us notice. But somewhere between measurement and meaning, we mistook noticing for understanding. That may be the message we missed. After the debates cooled and the telescopes turned away, something lingered, a sense of unfinished conversation. Even those who dismissed 3I, Atlas, as natural, couldn't ignore how human the experience had felt. We had projected curiosity onto an object of ice and gas, seen communication in its silence, and called it an anomaly when it refused to answer. Maybe it was never meant to. Maybe silence was the answer. In the aftermath, linguists and semioticians, scholars of meaning, no matter what, began studying the data that physicists had abandoned. They weren't looking for thrust or mass or orbit. They were looking for structure. They treated light curves like syntax, the brightness shifts like grammar. The jets, the pulses, even the intervals of absence all became symbols to be parsed, like hieroglyphs on a cosmic wall. One researcher at MIT's Media Lab proposed that 3I, Atlas wasn't transmitting a message at all, but performing one communication through rhythm, through change itself. It's not language, she wrote. It's choreography, meaning expressed as motion, not sound. That idea spread quietly through circles, tired of equations and hungry for poetry. Others disagreed. They said meaning requires intent, and intent requires mind. Without evidence of awareness, the talk of communication was projection, anthropomorphism, dressed in cosmic awe. Yet even the skeptics admitted the pattern was strange, the modulation too deliberate, the geometry too precise. It was as though every act of randomness had been edited for clarity. If not communication, then presentation. A display meant not to inform, but to be witnessed. Maybe it wasn't trying to tell us something. Maybe it wanted to show us how to look. In time, this interpretation became known as the mirror hypothesis. It suggested that the object was never an emissary, never a messenger, only a mirror, a cosmic instrument reflecting whatever intelligence looked into it. When we sought propulsion, it gave us thrust. When we sought language, it gave us rhythm. When we sought meaning, it gave us silence. Every answer matched the shape of our question. That realization broke something gentle inside those who'd been studying it, because it meant that the message had always been there. We just hadn't known what we were asking. A philosopher from Kyoto put it more simply. It taught us how to listen without expecting a reply. That line became famous, quoted in documentaries, whispered in classrooms, because it described something universal, the quiet ache of being seen by something that doesn't need to explain itself. Maybe intelligence doesn't always seek conversation. Maybe it seeks resonance. And resonance doesn't need translation. It just needs tension. In retrospect, every part of the event seemed symbolic. The sunward jet connection rather than avoidance. The expansion transformation instead of decay. The silence completion, not absence. Even its trajectory, bending neatly through the Earth corridor, felt like punctuation, the dot at the end of a cosmic sentence we still can't read aloud. And in that punctuation, the story of our perception was written. That is when the unknown doesn't conform to our grammar. We declare it unintelligible, never realizing we are the ones who can't yet speak its language. SETI veterans began reflecting on decades of listening for radio signals, narrowband tones, digital codes, anything resembling our own technology. They started to admit, quietly, that maybe the universe doesn't use frequencies at all. Maybe it uses phenomena. A comet that moves against gravity. A pulse of light timed to a planet's rotation. A silence at perihelion. Not messages, but gestures. And maybe we're only now learning to recognize them. It's strange the longer 3I, Atlas, stayed gone, the more it felt present. Artists painted its orbit like a halo around the sun. Poets described it as a note struck on the strings of space. Even engineers began to talk about its behavior, the way one speaks of character, not mechanics. As if, in the absence of language, we had found empathy. One evening, a linguist presented at an astrophysics symposium in Geneva. Her talk was titled Semiotics of the Sublime. She showed 2 slides. The first, the light curve of 3, I, Atlas rising, flattening, fading. The second, a human heartbeat. They were almost identical. The room went silent, not because anyone believed the object was alive, but because, for the first time, they understood what connection can look like without words. So maybe the message was never technical, never encoded. Maybe it was emotional, an invitation to feel wonder again in a universe that had grown too familiar. Maybe 3I, Atlas reminded us that intelligence, wherever it exists, begins not with communication, but with awareness. Awareness of being seen. Awareness of being part of something that doesn't need permission to exist. The longer we studied, the more we realized we weren't decoding a message. We were decoding ourselves. The data had become confession evidence, not of alien intent, but of human hunger for meaning. We wanted it to be talking to us, but perhaps it was teaching us to listen not outward, but inward. And yet, the object was never trying to stay. The universe rarely ends a story neatly. It prefers ellipses over periods, fading instead of finality. And yet, when 3I, Atlas, left, the departure felt scripted, as if the act of vanishing was the point all along. Long after the last recorded light curve, the object remained a ghost in data streams. Telescopes kept chasing the echo, hoping for a final glimpse, one last flare of reflection. But the coordinates kept coming up empty, not dim absent. That difference mattered. Dimness means distance, absence means choice. By late April, the official logs declared 3I, Atlas lost to observation. But within internal networks, astronomers were still talking, trading faint whispers from satellite arrays and deep space sensors. Some claimed to see a residual trace, a pattern of polarized light, inconsistent with background noise, like a shadow pretending to be a star. Others argued it wasn't gone at all, only hidden. That theory carried weight, because when they reconstructed its outbound vector, the geometry was too perfect. A path aligned precisely with the sun's magnetic equator, where solar wind scattering is strongest, a natural hiding place. The solar departure vector, as it came to be called, wasn't just escape. It was camouflage. Every model confirmed the same thing. It could have left at any angle, but it chose the one direction that guaranteed blindness, not from distance, but from design. Its path ensured that every major telescope, every orbital sensor, every ground-based observer would lose line of sight simultaneously. No overlap, no redundancy, a perfectly timed observational blackout. Coincidence, maybe, but it looked like a strategy. When the data was plotted in time, another pattern emerged. Its final detectable signal, a faint dip in background brightness, coincided almost exactly with a solar flare erupting on the opposite hemisphere of the sun. No causal link, just synchronicity. But if the flare's light had arrived 8 minutes earlier, and the same delay it takes sunlight to reach Earth, it meant that 3I, Atlas, vanished at the precise moment the sun's light reached it, as if it had been waiting for that cue, as if the sun had spoken, and the object had answered by disappearing. It wasn't destruction. There was no fragmentation debris, no dust plume, no trace of kinetic collapse, just smooth dissolution into invisibility, a retreat so perfect that it erased the act of leaving itself. Objects don't vanish like that. They decay, they disperse, they fail. But 3I, Atlas withdrew. It didn't die, it departed. In the following weeks, a phrase began circulating quietly through research circles. Anti-signal. It described what the object had left behind, not a transmission, but its opposite. An intentional absence of detectable data, a silence that carried the shape of purpose. Where ordinary signals fill the void with energy, the anti-signal creates meaning by removal. It tells you something was there by showing you where nothing remains, like footprints in dust-proof through negation. That idea fascinated physicists and philosophers alike. Was it possible to communicate by subtraction, to speak by vanishing, to leave a message whose power lay in its refusal to exist? R.V. Loeb wrote one last note to his students. Perhaps the greatest techno-signature isn't light or motion, but silence that organizes chaos. A civilization advanced enough to hide perfectly might also be advanced enough to choose when to be seen. For many, that was the first time disappearance felt like revelation, and then came the afterglow, not visible light, but data resonance. Days after the last sighting, several space weather satellites registered a faint alignment of cosmic ray flux, an oscillation so subtle it almost went unnoticed. It repeated exactly once, then faded. The interval matched the time it took 3I, Atlas, to complete its final rotation before crossing the solar plane. It wasn't noise, it was punctuation. Months later, the anomaly was confirmed by Gaia DR4, a minute phase shift in parallax readings across stars near the sun's limb, lasting only seconds. The distortion was too small to affect navigation, but large enough to raise eyebrows. It was as if space itself had rippled slightly, acknowledging something's passage. A door is closing quietly behind it. By then, public fascination had waned. The story had been absorbed by newer distractions, lunar mining, Martian weather, another probe gone silent in Jupiter's shadow. But among the few who still watched the corridor, there was a strange peace. They no longer expected contact or answers, only continuity, because somehow the vanishing had finished the sentence that words never could. It was as if the object had come to remind us that mystery itself can be complete, A scientist from Chile put it beautifully in her final report. Disappearance is not failure. It is the fulfillment of function. Perhaps 3I, Atlas was never here to be found, but to demonstrate that discovery has an endpoint, a moment when observation becomes communion, and communion dissolves into quiet. It had been seen. It had been recorded. It had been felt. And then, mercifully, it had left. That departure wasn't the end of its story. It was the story. We like to think the universe speaks in light, photons crossing emptiness, carrying truth. But maybe its rarest language is the opposite. Not illumination, but retreat. Not presence, but choice. Maybe the cosmos, like art, isn't meant to be stared at forever. Maybe some things are meant to vanish so that understanding can begin. Because there's humility in disappearance, a reminder that not every mystery asks to be solved. Some only ask to be, I noticed before they go. 3I, Atlas didn't crash. It didn't burn. It didn't fade into entropy. It simply stopped being visible. And somehow, that felt intentional, the way a curtain falls after the last note of a symphony, not to hide the performers, but to let silence finish the song. But we still have one way to understand it. When the light was gone, what remained was its fingerprint. And fingerprints, unlike witnesses, never lie. The James Webb Space Telescope, still orbiting quietly at L2, had been collecting spectra during the final visible weeks of 3I Atlas's approach. Its sensors were built for distance and dust, not mysteries, but what it found would haunt spectroscopy for decades. The data didn't look wrong. It looked incomplete, like a sentence missing its verbs. Peaks where there should be valleys, valleys where light should have bloomed, an orchestra missing every other note. To the untrained eye, it was noise. To scientists, it was a contradiction rendered in colour. The first surprise came from the CO2 ratio, nearly 8-to-1 over water. That's backwards. Comets, even exotic ones, carry water as their soul. Without it, sublimation collapses, tails fade, comas dissolve. But 3I, Atlas seemed to thrive on the imbalance, growing brighter as its water vanished. It was as though it breathed carbon instead of air. The ratio implied an engine, not an accident. Something controlling temperature and release, like a thermostat set just below detection. No heat signature, no radiation spike, only perfect chemistry. Then came the metallic anomaly. Spectral lines of nickel were clear, sharp, unambiguous, but the corresponding iron lines were missing. That's impossible. In nature, nickel and iron are twins born together in supernovae, bound forever in their atomic birth. You can't separate them without refining. To find nickel without iron was like finding a breath without a body. Even the instruments hesitated, recalibrating themselves, assuming malfunction. They weren't malfunctioning. The readings were consistent across every observation. Something in that object had been processed. A quiet memo circulated among spectroscopy teams, possible refined composition, suggestive of metallurgical differentiation. It was the most careful way imaginable to say what everyone feared. It looked manufactured, not constructed, not artificial, but touched, as if someone or something had once melted, filtered, or condensed its elements for a reason we couldn't decode. That theory didn't stay quiet for long. Word spread to the Planetary Science Institute, then to the Max Planck Institute for Astronomy, and soon every spectroscopist with clearance was re-examining old comet spectra, desperate to find precedent. None existed. No known object shared that combination of materials. The nearest analogues came from ironically human industry, alloys used in spacecraft plating to survive extreme radiation, nickel for strength, no iron for purity. The object wasn't metal, but it behaved like a memory of metal. The next clue lay in the light itself. 3I, Atlas, emitted no thermal signature above background, yet the scattered light carried polarization patterns characteristic of smooth, crystalline surfaces. In other words, reflection without heat, polish without friction, like glass engineered to stay invisible. But perhaps the strangest discovery was the one nobody expected: the missing dust. Typical comets are messy, tails of grit, ionized debris, clouds that trail for millions of kilometers. But JWST found nothing, not even a grain. The space behind 3I, Atlas was clean, pristine, as if the object refused to shed, as if loss itself had been disabled. One astronomer at the European Space Observatory wrote in her notes, "No dust means no decay means design." She deleted the line before submission, but her peers found it anyway. Eventually, a cross-agency team began assembling what they called the silent composition model. The goal was modest, to describe the object's behavior using chemistry alone. But chemistry refused to cooperate. When they modeled sublimation rates based on observed CO2 release, the object should have darkened within weeks. Instead, it maintained constant brightness. To maintain that equilibrium, it would have needed an internal source of pressure, carefully regulated, not chaos calibration. It was like watching entropy pause for balance. At one meeting, a data analyst proposed something radical. What if 3I, Atlas, wasn't emitting light at all? What if it was modulating it? Instead of being illuminated by the sun, maybe it was filtering incoming photons through a lattice of gas and microstructures, tuning reflection like an optical code. Each molecular layer is a note, each chemical absence is a rest. Spectra as symphony, chemistry as communication. No one could prove it, but no one could dismiss it either. When the team ran time-resolved spectroscopy, another pattern emerged. Across hours of observation, certain spectral lines shifted faintly, rhythmically, as though oscillating in time. Every cycle matched the object's rotation rate. The colors pulsed in step with movement. Nature doesn't sync that perfectly, but instruments do. Designs do. Each turn of the body replayed the same chemical melody, a repeating chord in light, invisible to human eyes. NASA called it a coincidence. ESA called it transient, instrumental coherence. But privately, one scientist described it better. It's like it was showing us what a perfect reflection looks like. And that phrase, perfect reflection, began to feel less metaphorical and more literal. Because every reading, every data set, every trace of evidence led back to the same absence. The more precisely they measured, the less there was to see. It wasn't deception. It was a restraint. When the final data set was published, it came with an appendix titled Undetectable Anomalies. The list was short but haunting. No dust emission. No water lines. Nickel without iron. Constant brightness at variable distance. Zero detectable heat signature. Each line alone meant little. Together, they formed something like intent. It was as if the object wanted to be studied but not solved. Visible enough to invite wonder, precise enough to deny certainty. A riddle made of chemistry. The last note in the JWST summary said simply, unclassifiable by current models. Recommend passive observation until further events. Even in that bureaucratic caution, there was reverence. Because every scientist who touched the data knew they were staring at something that refused to decay, refused to age, refused to be random. A monument not of matter, but of behavior. And what the data doesn't show, it may matter more. There comes a point in every investigation when the unknown stops growing larger and begins to fold back toward us. 3I, Atlas had crossed that threshold long ago. But only now were we beginning to realize that the limits of discovery weren't out there. They were in here, inside. The minds trying to measure it. Months after the last data packet from JWST was catalogued, the scientific community found itself tired. Not defeated, just drained. It wasn't the object that had exhausted them, it was their own reflection in its mystery. They called it anomaly fatigue, a quiet burnout that comes from confronting evidence that won't fit again and again until curiosity turns to numbness. When every model breaks, even wonder starts to feel repetitive. At first, the exhaustion hid behind productivity. More models, more simulations, more attempts to hammer coherence out of paradox. But the data refused to change, and the act of explaining began to feel like erasure, each new theory smoothing away the very strangeness that made the discovery sacred. In that flattening, something essential was being lost. One researcher at the European Southern Observatory wrote privately, "We keep trying to drag it down to our level of understanding, when maybe the work is to let it stay above us." It was the first time the conversation shifted from comprehension to acceptance. Epistemology, the study of how we know what we know, suddenly became fashionable again. Physicists started reading philosophers. Mathematicians quoted mystics. Everyone seemed to sense that the old boundaries of scientific culture, skepticism, rigor, repeatability were rubbing against a deeper limit, a kind of ceiling made not of ignorance, but of identity. Because to truly see something beyond us, we'd have to stop insisting on being the center of it. In quiet corners of academia, they began asking forbidden questions. What if we're not equipped to perceive certain kinds of order? What if our instruments detect what we expect them to, reinforcing the stories we already believe? What if observation itself, by its act of framing, prevents revelation? The observer effect wasn't new, but 3I Atlas had turned it existential. We weren't just shaping what we saw, we were limiting what could be seen. By mid-2028, a few brave journals started publishing essays under titles that sounded more like confessions than science. On the limits of cosmological comprehension, data beyond description, the shape of what we can't know. They weren't failures. They were letters of surrender, beautiful ones. They marked the moment when science stopped fighting mystery and started coexisting with it. And in that surrender, humility blossomed. A group at Caltech coined a new term, the human threshold. It meant the edge of cognition, the place where information stops being knowledge and becomes awe. The idea wasn't to give up, but to recognize that some truths can't be reached by force, that maybe understanding isn't always an act of conquering the unknown, but of aligning with it. They compared it to listening for faint music in a storm. You don't silence the storm, you quiet yourself. Workshops began blending disciplines that had never shared rooms before, astrophysicists with poets, linguists with engineers. Together, they discussed not how to decode anomalies, but how to approach them differently. They began treating data like dialogue rather than evidence. Each spike, each silence, a response in a conversation too subtle for translation. One evening, during one of these sessions, a linguist drew a single line on a whiteboard, curved, incomplete. Then she said, "This is what knowledge looks like when it's honest, incomplete, because completeness belongs to the gods." That moment shifted everything. For centuries, science had defined itself by its certainty, the ability to draw full circles around mystery. Now, for the first time, it began to cherish the curve that never closes. Perhaps that was the true legacy of 3I Atlas. Not proof, not revelation, but recalibration. It had forced us to rediscover reverence not as superstition, but as methodology. The more humanity stared into the void, the more the void began to resemble a mirror. Every unanswered question illuminated something about the asker. Every failed model exposed a hidden assumption. Every silence echoed back our own noise. In trying to know the object, we'd uncovered ourselves. Eventually, a small team at MIT proposed a new framework neither purely scientific nor spiritual. They called it participatory observation. The premise was simple. The universe doesn't reveal itself when dissected, but when witnessed with balance half inquiry, half stillness. They tested the model on archival data. The results weren't measurable, but those who participated said they felt something different. The data seemed to breathe. Patterns appeared softer, less combative. A physicist described it perfectly. It's like the universe started whispering instead of screaming. That shift, small, almost imperceptible, marked a turning point. For once, the frontier of science didn't expand outward, it expanded inward. The next great discovery wouldn't come from a telescope, but from attention itself. Because 3I, Atlas, had taught us that awareness can be an instrument too, and sometimes silence is what calibrates it. The final conferences on the event sounded less like lectures and more like confessions. People spoke softly, as if afraid to disturb something sacred. They no longer debated what 3I Atlas was. They reflected on what it did to us. It had humbled a species drunk on explanation. It had reminded us that knowledge without wonder is just inventory. That maybe truth isn't what fits neatly in equations, it's what survives when the equations end. The last slide of the last presentation read simply, We have reached the threshold. Beneath it, in smaller letters, and when we stop trying to explain, we might start listening. There comes a point in every investigation when the unknown stops growing larger and begins to fold back toward us. 3I. Atlas had crossed that threshold long ago. But only now were we beginning to realize that the limits of discovery weren't out there. They were in here, inside the minds, trying to measure it. Months after the last data packet from JWST was catalogued, the scientific community found itself tired. Not defeated, just drained. It wasn't the object that had exhausted them, it was their own reflection in its mystery. They called it anomaly fatigue, a quiet burnout that comes from confronting evidence that won't fit again and again until curiosity turns to numbness. When every model breaks, even wonder starts to feel repetitive. At first, the exhaustion hid behind productivity. More models, more simulations, more attempts to hammer coherence out of paradox. But the data refused to change, and the act of explaining began to feel like erasure, each new theory smoothing away the very strangeness that made the discovery sacred. In that flattening, something essential was being lost. One researcher at the European Southern Observatory wrote privately, "We keep trying to drag it down to our level of understanding, when maybe the work is to let it stay above us." It was the first time the conversation shifted from comprehension to acceptance. Epistemology, the study of how to know what we know, suddenly became fashionable, again. Physicists started reading philosophers, mathematicians quoted mystics. Everyone seemed to sense that the old boundaries of scientific culture, skepticism, rigor, repeatability, were rubbing against a deeper limit, a kind of ceiling made not of ignorance, but of identity. Because to truly see something beyond us, we'd have to stop insisting on being the center of it. In quiet corners of academia, they began asking forbidden questions. What if we're not equipped to perceive certain kinds of order? What if our instruments detect what we expect them to, reinforcing the stories we already believe? What if observation itself, by its act of framing, prevents revelation? The observer effect wasn't new, but 3I, Atlas, had turned it existential. We weren't just shaping what we saw, we were limiting what could be seen. By mid-2028, a few brave journals started publishing essays under titles that sounded more like confessions than science. On the limits of cosmological comprehension, data beyond description, the shape of what we can't know. They weren't failures. They were letters of surrender, beautiful ones. They marked the moment when science stopped fighting mystery and started coexisting with it. And in that surrender, humility blossomed. A group at Caltech coined a new term, the human threshold. It meant the edge of cognition, the place where information stops being knowledge and becomes awe. The idea wasn't to give up, but to recognize that some truths can't be reached by force, that maybe understanding isn't always an act of conquering the unknown, but of aligning with it. They compared it to listening for faint music in a storm. You don't silence the storm, you quiet yourself. Workshops began blending disciplines that had never shared rooms before. Astrophysicists with poets, linguists with engineers. Together, they discussed not how to decode anomalies, but how to approach them differently. They began treating data like dialogue rather than evidence. Each spike, each silence, a response in a conversation too subtle for translation. One evening, during one of these sessions, a linguist drew a single line on a whiteboard curved, incomplete. Then she said, "This is what knowledge looks like when it's honest. Incomplete. Because completeness belongs to the gods." That moment shifted everything. For centuries, science had defined itself by its certainty, the ability to draw full circles around mystery. Now, for the first time, it began to cherish the curve that never closes. Perhaps that was the true legacy of 3I Atlas. Not proof, not revelation, but recalibration. It had forced us to rediscover reverence not as superstition, but as methodology. The more humanity stared into the void, the more the void began to resemble a mirror. Every unanswered question illuminated something about the asker. Every failed model exposed a hidden assumption. Every silence echoed back our own noise. In trying to know the object, we'd uncovered ourselves. Eventually, A small team at MIT proposed a new framework neither purely scientific nor spiritual. They called it participatory observation. The premise was simple. The universe doesn't reveal itself when dissected, but when witnessed with balance half inquiry, half stillness. They tested the model on archival data. The results weren't measurable, but those who participated said they felt something different. The data seemed to breathe. Patterns appeared softer, less combative. A physicist described it perfectly. It's like the universe started whispering instead of screaming. That shift, small, almost imperceptible, marked a turning point. For once, the frontier of science didn't expand outward. It expanded inward. The next great discovery wouldn't come from a telescope, but from attention itself. Because 3I, Atlas had taught us that awareness can be an instrument too, and sometimes silence is what calibrates it. The final conferences on the event sounded less like lectures and more like confessions. People spoke softly, as if afraid to disturb something sacred. They no longer debated what 3I, Atlas was. They reflected on what it did to us. It had humbled a species drunk on explanation. It had reminded us that knowledge without wonder is just inventory. That maybe truth isn't what fits neatly in equations. It's what survives when the equations end. The last slide of the last presentation read simply, "We have reached the threshold." Beneath it, in smaller letters, and when we stop trying to explain, we might start listening. Silence, it turns out, was never empty. It was cartography. Every unanswered question, every unrecorded signal, every failure to observe. Together they formed something larger than understanding, a shape of absence, a map written not in stars but in the spaces between them. Months after the last observation of 3I, Atlas faded from data. A new discipline quietly emerged. It wasn't astronomy, nor theology, nor art. It was something between them, an act of interpretation without possession. They called it cosmic semiotics, the study of meaning without translation. Its first principle was simple and radical. If the universe doesn't speak our language, maybe it's because it's writing in something older. A grammar of rhythm, recurrence, and silence. Instead of chasing noise, these new thinkers began charting its absence. They treated quiet as data, randomness as a message. Patterns of when things didn't happen began revealing their own constellations. The universe wasn't ignoring us. It was composing. The turning point came when one analyst overlaid every silence window from all major observatories. During the 3I, Atlas encountered the nights when weather, maintenance, or solar interference had stopped data collection. The resulting pattern wasn't random. Each blind spot aligned with a major celestial event, a meteor shower, a planetary opposition, a flare from a distant quasar. As though the cosmos itself had choreographed our interruptions. It was as if the universe knew when we were looking away, and chose those moments to adjust the script. Philosophers saw poetry in that. Scientists saw correlation without causation. But for once, neither side argued. They simply sat with the mystery, because the idea was too beautiful to need proving. If silence is part of the design, then ignorance is sacred too. If gaps are deliberate, then wonder is a form of participation. At a symposium in Kyoto, an astronomer opened her keynote with a single slide, a blank graph, labelled "The Data We Didn't Collect." She said nothing for 60 seconds, just stood in quiet. Then she whispered, "This is the most accurate model of the universe we've ever made." No one laughed. A few cried. That moment became known as the Kyoto pause, a ritual repeated at every conference thereafter. A minute of silence not for mourning ignorance, but for honouring it. As the movement grew, the tone of scientific writing softened. Papers ended not with conclusions, but with invitations. What else could this mean? Footnotes gave way to reflections. Data tables were paired with poems. The language of measurement began to sound, quietly, like gratitude. Some critics called it regression, a return to mysticism. But those who had lived through 3I, Atlas knew better. It wasn't mysticism, it was maturity. They started describing reality not as a solved equation, but as a breathing system of meaning. Every orbit, every failure, every silence part of one vast rhythm. The laws of physics hadn't changed. Our relationship to them had. To accept ambiguity wasn't to surrender. It was participation in the unfinished. The cosmos, they realized, was a conversation written by no one and everyone at once, and slowly, humanity's posture shifted. We stopped looking up at the sky as something separate. We began to look into it, recognizing ourselves in its stillness. The stars were no longer distant. They were mirrors for the part of us that had finally learned to listen without demanding. Meaning, the myth of separation had ended. The great paradox of 3i, Atlas, was that it never spoke, yet somehow changed the way we hear. Its message wasn't in words or numbers, but in the quiet architecture of its passage. Arrival, transformation, disappearance. It was a story without translation, a ritual of return. Across cultures, people began reinterpreting it in the language of their own traditions. Some called it the silent teacher, others, the mirror comet, and a few simply called it the reminder. Whatever the name, the feeling was the same, that the universe had paused long enough for us to remember we are part of it. When theologians joined the conversation, they didn't argue for divinity or deny science. They simply said, the divine may not be who speaks, it may be the space that lets speaking happen. Physicists nodded. For once, everyone was describing the same thing in different dialects. By the end of that year, the phrase map written in silence had become shorthand for a new way of knowing. Not discovery, but discernment. Not conquest, but conversation. The old tools still mattered: telescopes, models, equations. But now they shared the table with meditation, art, and reflection. Observation had expanded to include stillness, because the closer we got to understanding, the more we realized understanding wasn't the point. Attention was. When new anomalies appeared, small, faint, almost identical to the first, no one panicked. No one rushed to label them. Instead, telescopes turned slowly, respectfully, as if greeting an old friend returning in disguise. The narrative had shifted from fear to familiarity. Mystery no longer meant danger. It meant continuity. The sky was still the same. We were the ones who had changed. A final paper from the Interstellar Observation Network ended with one line, unsigned. If meaning is everywhere, proof is no longer required. It wasn't arrogance. It was acceptance. Because sometimes the echo is enough. For centuries, we imagined ourselves at the center of every message, every flash of light, every radio hiss, every anomaly we assumed it was meant for us. But what if we were never the audience? What if we were only within earshot? When the last echoes of 3i, Atlas faded, a quiet realization began to spread through the astrophysics community. We'd been interpreting cosmic noise as conversation. But maybe it was just sound, the ambient murmur of a universe too vast to care who hears it. It wasn't a message. We were simply standing close enough to overhear one. The term signal horizon was coined to describe it, the invisible boundary where information exists but meaning dissolves. Everything beyond that limit still happens. We just stop being the reference point. And in that decentering, something beautiful emerged. A new kind of listening, free of expectation. Instead of asking, what are they saying to us? We began to ask, what are we hearing between them? The first experiments under this new paradigm were called ambient astronomy. Instead of isolating sources, telescopes began recording entire fields of interference. Solar winds, magnetar pulses, dark matter simulations, and background hum. The goal wasn't clarity, but context. To listen not for signal, but for relationship. It was like changing the station from words to weather. The data came alive in ways no one expected. When filtered through deep learning systems, the ambient noise formed emergent harmonics, patterns that seemed to breathe, fluctuate, and evolve. It was as if the universe was improvising. No syntax, no sender, just resonance. From that point on, Earth stopped being the target of its own curiosity. We became the microphone, not chosen, not addressed, simply positioned. Our planet wasn't the recipient of cosmic intent. It was the perfect accidental listener. And that shift changed everything. We began to study not what we received, but how we received. How the magnetic field sculpted space noise. How the ionosphere bent and softened radiation like a giant ear. how the atmosphere translated gamma bursts into ghostly whispers. It turned out Earth itself was a listening instrument, tuned by its oceans, resonating through its crust, recording centuries of starlight like grooves in an ancient record. We'd always assumed listening required technology, but the planet had been listening long before we arrived. In one experiment, a group of physicists translated satellite data into audible frequencies and played it through hydrophones across the Pacific. Whales responded, not randomly rhythmically. The pattern matched the amplitude of solar winds, recorded that same week. No one could explain it, but the implication was profound. The Earth wasn't just receiving, it was participating. The biosphere, the magnetosphere, the atmosphere, each layer echoing the cosmic environment like nested drums in a universal orchestra. We weren't isolated minds looking outward. We were vibrations within vibrations. That discovery inspired a philosophical shift, sometimes called the Great Reorientation. It said, if intelligence exists elsewhere, it doesn't need to aim to be heard. Everything it does ripples, and the universe being what it is records those ripples everywhere. Listening, then, becomes a form of belonging. We are not the audience. We are witnesses. And witnessing doesn't demand interpretation, only presence. For the first time, cosmic research started sounding like meditation. Observation became listening. Analysis became stillness. Instruments were recalibrated not just for sensitivity, but for humility. Scientists began to write field notes like prayers. We recorded a whisper between two neutron stars. It was not for us, but we were here, and we heard it. That was enough. Even technology began to evolve in sympathy with this new worldview. Satellites were designed to listen gently, recording without disturbing surrounding frequencies. AI systems were trained not to detect anomalies, but to feel continuity, the slow, breathing texture of space. Data visualizations became art forms, flowing shapes of resonance instead of discrete plots. Each stream of numbers felt less like discovery, more like participation in a timeless performance. Meanwhile, philosophers revisited the question of meaning. Maybe, they said, the universe doesn't send messages because it is the message. Everything that happens, the collisions, the silences, the light is expression. And we, as observers, are the accidental translators of an eternal monologue. But even monologue isn't quite right. Because to listen deeply enough is to realize it's all dialogue. Matter and energy are conversing, gravity and void trading secrets. We are the echo caught in the middle, believing ourselves to be the source. In time, a new kind of humility took root, cosmic humility. Not the smallness that breeds despair, but the vastness that breeds peace. To know that we are not being watched or addressed doesn't make us meaningless. It makes us witnesses to a meaning too vast to claim. The quiet realization dawned, we don't need to be the subject of the story to belong to it. Late one night, an astronomer in Chile wrote in her log, the sky doesn't notice us, but it lets us listen. And maybe that's what grace feels like. The sentence spread through scientific circles like scripture, because it named something everyone had felt but couldn't articulate, the strange serenity that comes from being irrelevant, but included. The stars keep speaking, indifferent and infinite, and Earth, this small, soft receiver, keeps humming in response. We were never the target. We were the echo chamber, the place where the universe hears itself, and what we overhear might change us. The sky never closes. It only exhales. And somewhere in that breath, beyond the dust, beyond the dying echoes of 3I, Atlas, another silence is forming. Another whisper, not yet visible, but already arriving. Months have passed. The telescopes rest, though no one really believes in rest anymore. Every data feed feels like an ear pressed to the dark, listening for the next tremor of coincidence. Nothing unusual yet. But then again, that's what we said last time. In the archives, scientists still replay the old light curves, not for answers, but for rhythm. They treat the data like music now, tracing the same crescendos, the same fading chords. It's as if they're waiting to recognize a melody. Because melodies, unlike events, tend to return. Someone once said that the universe doesn't repeat itself. But maybe it rhymes. Across observatories, A new protocol quietly circulates. Open sky listening. Every sensor now leaves a fraction of its bandwidth unassigned. A small window of patience in the machinery, a listening gap for the unknown to speak again. It's superstition disguised as science. And yet, every engineer honors it. Because after 3, Atlas, no one wants to close the door completely. At a conference in Geneva, a physicist opened her keynote not with data, but with a single line projected on the screen. Maybe the universe whispers, and we just caught the first syllable. She let it hang there for a full minute. No slides, no numbers, only the hum of the ventilation system and the faint beating of hearts trying to hear. When she finally spoke, it was to remind them that the most important part of any discovery isn't the discovery itself, it's the space it opens, the questions that stay lit after the facts burn out. 3. Atlas was one of those spaces, a doorway carved in silence. And the air on the other side still feels electric. Even the public hasn't forgotten. At night, people look up differently. They don't search for miracles, they listen for them. Videos titled "Another Object Approaching" circulate online. Most of them are false, a few hauntingly familiar. Each new rumor carries less panic and more reverence. Humanity has learned to let awe arrive without needing control. We used to crave proof. Now we crave presence. In a quiet lab outside Tokyo, a spectroscopist compares background readings between hemispheres. Buried deep in the noise, she notices a faint oscillation. A modulation so delicate it could be a coincidence or continuation. She doesn't alert the press. She doesn't call it discovery. She just labels the file, possibility 1, and saves it for the next generation. Because that's what the universe taught. The unknown doesn't reward possession, only patience. Somewhere else, in a desert observatory, a technician on night shift pauses before shutting down the system. He listens to the static in his headphones, a wash of white noise that once felt meaningless. Tonight, it feels alive. He swears he hears a rhythm under the chaos, a pulse almost human in its calm. He doesn't tell anyone. He just smiles and whispers into the dark. Welcome back. In schools, children now learn about 3 Atlas not as a comet or a probe, but as an encounter, a chapter in the story of how humanity learned to listen again. Textbooks describe it as a turning mirror. The moment science remembered to include wonder in its equations, and on the final page, a small line reads, "The universe is not finished speaking. The lesson it left behind is gentle but irreversible, that not every silence is absence, not every mystery demands a solution. Some exist simply to realign the listener." It changed the hierarchy of curiosity. Instead of, "What is it?" we now ask, "What does it reveal about us?" The answers are quieter, but infinitely more precise. Late one night, under the still air of the Atacama Plateau, a group of researchers gathers outside after calibrating a new array. They lie on their backs, no instruments, no metrics, just eyes. Above them, the Milky Way spills across the sky like frozen breath. Someone sighs and says, "If they're out there, they're probably wondering the same about us." Another answers softly, "Maybe we're all just pieces of the same whisper." No one replies. There's no need. The silence finishes the thought. And then, faintly, on the edge of measurable light, a flicker. A point too small to name, too early to confirm. The observatories will catch it soon enough, but for now, it's just a shimmer. The first vibration of curiosity returns. The next whisper. Already on its way. When it comes, it will not announce itself. It will not prove or disprove anything. It will simply be, and the world will pause again, not in fear this time, but in recognition, because we've heard this tone before, the frequency of wonder. So we wait, not as seekers of answers, but as participants in the ongoing breath of the cosmos, listening, remembering, ready to greet whatever arrives with the same quiet grace 3 Atlas taught us. Because maybe every arrival is a rehearsal for attention, and every departure is a beefer, the reminder to stay awake. The universe exhales. The data hums. Somewhere, a new anomaly flickers in the dark, a question wearing the disguise of light, and though no one can say what it means, we already understand the rhythm. It wasn't a message, but it meant something.